Yeah,
Good morning to all the delegates and welcome to the third day of the short term course. Our lecture is just about to start in a few minutes. सही था।
Good morning, Professor Vyas.
Good morning. Good. Am I audible?
Yes, sir, you're audible.
Okay. हाँ जी, आप सभी को नमस्कार।
नमस्कार सर।
सर गुड मॉर्निंग सर, नमस्कार सर।
हाँ, मैं एक काम करता हूँ, मैं एक बार जरा अपना प्रेजेंटेशन लगा के देख लेता हूँ, यहाँ से चल जा रहा है या नहीं चल जा रहा है, ठीक है?
जी सर, एज यू फील कंफर्टेबल सर।
हाँ, एक बार मैं वो ट्राई कर लेता हूँ तो बेहतर रहेगा।
मैं बोल चुका हूँ उनको।
ये प्रेजेंटेशन विजिबल है आपको?
Visible.
Whether presentation is visible?
Yes, sir, it's visible.
Yes sir.
Okay. I will just check.
A very good morning to all the delegates. I welcome Professor Rajkumar Vyas, our expert speaker for the day. Dr. R.K. Vyas is a professor in Department of Chemical Engineering at MNIT Jaipur. He has done his BE in Pulp and Paper Engineering from University of Rajasthan, Jaipur, post-graduation and PhD in Chemical Engineering from IIT Roorkee. His research areas are chemical reaction engineering, separation processes, industrial pollution abatement, and biotechnology. Presently, he is working in the area of industrial pollution abatement and heterogeneous catalysis, focusing separation processes involving adsorption and reactive adsorption, water and wastewater treatment. Dr. Vyas has published 29 papers in peer-reviewed journals and 56 papers in conferences. He has supervised 7 PhD theses and 15 MTech dissertations. He has delivered a number of keynote lectures and invited talks in a large number of institutions and conferences. Dr. Vyas will give his talk on the topic Advanced Separation Processes and Bioseparations. I welcome you, sir, to this morning session of STC, and I request you to start your lecture and share your experiences with the delegates. Thank you, sir.
Thank you, ma'am. Small correction is there. You introduced very nicely. One thing was there. You said I did my B from University of Roorkee. Actually, it is written UOR. That means sometimes University of Rajasthan also. But actually, IIT was known at that time University of Roorkee. So I have done all 3 degrees from University of Roorkee, which has now converted into IIT Roorkee. That's the only small correction.
Okay, sir.
Yeah.
Thank you, sir.
Let us go ahead with the presentation. I hope the presentation is visible.
Yes, sir, it's visible and clear.
Okay.
I think it can be done as full screen if it's possible.
Yeah, it is possible. Okay. Yes. I hope it is now okay.
Yes, sir, it's absolutely fine.
Right. So, good morning to all the participants. I wish to say that this advanced separation processes and bioseparations on which we are going to discuss today, separation processes are very important part of our life. In our body, there are several separation systems. In fact, if we do not have separation system in our body, the body cannot function the way we want. Same way, in industries, separations are very important. And sometimes in some of the processes, they constitute a major part of the cost of the product. Number one. Number two, we do not have the requisite quality of product which we want to produce. So separation processes are very important, and we have number of separation processes. We have mechanical separations, we have advanced separations, and we have several separation processes in our bio processes, which we call it bioseparations. So bioseparation means we are not talking about our living system, but we will be talking about the industrial systems where bioseparations are being carried out. Means mostly it is based on cells, microbes, and or other living systems. So in the beginning, in our talk, I will discuss first the normal separation systems, what we follow. Then we discuss about the advanced separation processes, and at last we will discuss. Of course, I must thank you in the beginning, the convener of the course, Professor Ajay Bansal, Dr. Renu, Dr. Poonam Gira, and Department of Biotechnology, Center for Energy and Environment, NIT Jalandhar. I must thank you. I must thank National Institute of Technology, Jalandhar, for inviting me for this talk. So let us start our first slide. In the beginning, let's have an introduction. Separation of one or more components from a complex mixture is a requirement for many operations in any industry. As I said, separation is very important for most of the products. We will discuss about those products. We will talk about the critical points why separation is necessary. When we talk about industry, most of the industries, because of their operation, cause some environmental pollution, and those environmental pollution can also be relieved, can be mitigated by the help of separation processes. And you know, pollution is basically placement of right thing at a wrong place. So when something which is coming as a contaminant, as a pure component, it may have commercial value, but as a contaminant, it will have very detrimental effect to the product which we are using. So pollution again needs separation processes. Pollution abatement also needs separation processes. Now, the second point, choice of separation techniques is based on the type of mixture and difference in the chemical properties of the constituents of the mixture. When we talk about this, separation techniques need some basis for separation. It may be gravity, it may be size, it may be shape, or it may have some other properties, difference in properties like relative volatilities, which we use in case of distillation. So separation process needs some base, which we will be talking later on also. And then components range from particulate materials down to small molecules. When we talk about separation process, we may have particulate materials, we may have gases. Gases can be also separated from a gas mixture where two or more gases are present. And sometimes we may have smaller molecules, larger molecules in a mixture, so we can size. In that case, we use some kind of advanced separation process, because the molecules, as you know, are very small when we see about our visual capacity, because molecules cannot be seen as individually by our naked eyes. Now, types of separation processes. We have from beginning, let us start from sedimentation, because sedimentation is a process of removal of solid particles from a a solid liquid mixture or solid gas mixture. This is the most economic process. So whenever we attempt for whenever we attempt for separation, if sedimentation is possible, we go for sedimentation. If sedimentation is not possible, or the separation is not possible using sedimentation, then we go for filtration. Again, filtration is a separation process based on size of the particle, and we use some kind of a medium for filtering out or for separating solid particles. Then let us see, if filtration is not possible because of some reason or the other, then we go for centrifugation. In sedimentation, we use gravity as a force for separation. In filtration, we use size, pressure as a force for removal of particles from the liquid or gas stream. And in centrifugation, we use centrifugal force. So when we find that there is some difficulty separating solid liquid mixture or solid gas mixture through filtration, we go for centrifugation. Now we should also understand that by going from sedimentation to centrifugation, the cost increases, because centrifugation, we use centrifugal force which is obtained by a high rotational velocity. That can be obtained from high rotational velocity only. So centrifugation is expensive, more expensive than filtration. Now, if we see that it is not possible from separation from centrifugation, then we go for other means. Of course, the nature of mixture may be also different. Then if we have, we can go for evaporation. In evaporation, we have to apply thermal energy. Now, you know, thermal energy is again very costly. So when we find that these things are not applicable, we can go for evaporation. So when the solid is present in solution form, when the particle size is very small, then we go for evaporation. Of course, we cannot resort to evaporation when we find that the solid material or liquid material is sensitive to temperature or thermally sensitive. Then we go for some other method. But if they are not thermally sensitive, then we go for evaporation process. So we will discuss about evaporation also, types of evaporation and equipment also. Because in the beginning, I wanted to discuss the basic separation systems so that we are very clear about the other way. Now, in distillation, we go for miscible liquids. When we have two miscible liquids, then, and if you want to separate them, then if there is a difference in their relative volatilities, then we go for distillation. We boil the mixture and we separate on the basis of their boiling point difference. So that is distillation. Of course, this is quite used in bioseparation systems. Evaporation is lesser used because bioseparation processes, the materials or constituents which we handle are thermally sensitive. Then if we do not, if we cannot follow distillation, evaporation and those, then we go for, of course, I will talk little later. First, let me talk about crystallization. If we can separate out by crystallizing the solid molecules from the liquid mixture, solid liquid mixture, then we crystallize also. But then the solid must have the ability to form crystals. If it is amorphous, then it is not possible. If they can form crystal, then we go for crystallization. And last one, this is membrane separation processes, which come under advanced separation processes, or we also call them as novel separation processes. So membrane separation are also important. We will discuss later on. Now, classification of separation processes, which I was talking to you: mechanical separation, filtration and centrifugation, diffusional separations, distillation, absorption and extraction, Of course, we will not talk about much about absorption. Absorption, you know, we can remove gases by using some liquid in which the gas is soluble. So that is another separation process. So from a gas mixture, we can utilize absorption for removal of a selective gas. Then we have extraction. Extraction also is used for say liquid solid mixture or liquid mixture. Liquid mixture is extraction, and for solid liquid mixture we have leaching. So that's also a separation process. And last one is membrane separations. We have 4 kinds of membrane separation processes: microfiltration, ultrafiltration, nanofiltration, reverse osmosis, and few more. We will discuss about that. Dialysis, and some other also. So a few more are also there. They are less in numbers, but they are still there. So that is about membrane separations. Now, sedimentation. For separation of solid liquid mixture, we use gravity. As I said, it is most economical method. We use the gravity force of particles which are present. So we reduce the velocity of liquid so that the particle can settle down under the influence of its own gravity. Sedimentation relies heavily on gravity to separate suspended solids from fluids. As I said, our first attempt is to go for sedimentation. If we can separate the suspended solid from liquid or from gas, we can go for we should go for sedimentation, because this is most economical process. It does not require any external force. So we do not have to consume any kind of energy in this. Only thing is that we have to reduce the velocity of flowing liquid or gas. As you know, for sedimentation in our liquid systems, we have clarifiers, we have thickeners, and for gas solid systems, gas solid mixtures, we have gravitational chamber, we have tray settling chamber for gas solid mixtures, which are used for removal of suspended solids from flue gases or any gas in which those solid particles are present. Of course, that is again for gas solid mixtures. We have other techniques also. We will discuss about that also. When the velocity is no longer supports the transport of the particles, gravity will remove them from the flow. So we reduce, our attempt is to reduce the velocity of liquid so that the particles can settle down and get separated in a form of slurry or sludge in case of liquid, or in case of gas solid, they are separated as dry solids. So this is very desirable process. Next is application of sedimentation. We have application in pulp and paper industries. We have chemical recovery system in pulp and paper industry, which is commonly known as soda recovery process. There we use clarifiers to remove the solids which are present there, that they call it as green liquor. From green liquor, they separate out this sludge using clarifiers. In water treatment, when we are taking some water from surface source like river or any pond or a reservoir, then there are suspended solids in that, and we remove it through sedimentation. In wastewater treatment, we have 2 levels of sedimentation. One is for the wastewater which is coming directly from there, so that we can remove the suspended solids. And in second case, in aerobic systems, we add some kind of microbes. Those microbes are to be removed because they are recycled back into the system, and the system is known as activated sludge process. And there we use again sedimentation for removal of microbes for recycling back to the system. Again, sedimentation, as I said, there are examples in gas solid system which are used in air pollution control, which I said gravitational settling chamber or tray settling chamber. Next is filtration. For solid liquid mixture separation, we use pressure energy. As I said, this is the next in our sequence of preference after sedimentations, because it needs pressure energy. Filtration is the mechanical separation of solid particles from a fluid using a filtering medium on which these solids are deposited. Now, in this case, when the solids are deposited on the pores of the filtering medium, they form a kind of cake, and that cake also provides a filtering medium. So with passage of time, the thickness of cake goes on increasing, and that also provides a filtering medium. Of course, with time, the pressure requirement increases because porosity of the medium decreases because of the formation of cake. And with time, the cake is also compressed, and with compression, the porosity further decreases. So this becomes finally a batch process, because a situation comes when the porosity is so high, porosity is so low that the pressure requirements are very high. So in that case, we have to stop the process and remove the cake, and again it has to be used back after removal of cake. So it becomes a batch process. Okay, the most common filtering medium is fabric cloth with strong mechanical properties. Of course, fabric cloth, even metallic clothes are also there. Metallic wires are also used, and sometimes there is a blend of synthetic fabric and metal wires to give it more strength. Type of filtration and application. We have plate and frame filter press. It is a batch process, as I said. Edible oil industries use it. Calcium carbonate slurry can also be separated by using, but it is a batch process. Then we have, for a continuous process, in I think late 18th century, rotary drum vacuum filters were developed. Okay, and they are used very widely nowadays. They are used in sugar industry. They are used in pulp and paper industry. In sugar industry, the sugar cane juice is filtered using this rotary drum vacuum filter. And in pulp and paper industry, again, the pulp which is made from, say, wood or say any other raw material, it is again filtered out from the caustic slurry or the chemical slurry which is used for pulping. It is sodium hydroxide, and in craft process it is a mixture of sodium hydroxide and sodium sulfide. So that is in the form of liquid. So after pulping, that chemical becomes almost very dark brown, and it is called as black liquor. And because it solubilizes the lignin which was present in wood chips, so that is to be separated. The pulp has to be separated from this, and for that rotary vacuum filtration is used. Of course, there it is a three-stage process for filtration, because filtration is done and washing of sludge of the pulp is also done. So it is three-stage process. In sugar industry, it is only a single stage for rotary drum vacuum filter. Now, looking at the success of this, rotary drum pressure filter was also developed. Of course, it is used not very commonly. Very limited applications are there. Liquefied gas slurries can be filtered out using rotary drum pressure filters. Then we have leaf filters. Leaf filters are used for low solid content slurry which are less than 5%. And they are mostly applicable for flammable, toxic or corrosive substances, leaf filters. There are several types of leaf filters also. Then we have centrifugation. As I said, something which cannot be separated using filtration, we go for centrifugation. And in centrifugation, we use centrifuges, and centrifuge is rotated at very high speed. So for solid liquid mixture separation using mechanical energy, we use mechanical energy. Of course, electrical energy is getting converted into mechanical energy that is used for centrifugation purpose. Centrifugal force, of course, is used for separation here. It is the process of separation of insoluble materials from a liquid where filtration does not work well. It is based on size, shape, and density of particles. We have different types of centrifuge. We have low speed centrifuge, we have high speed centrifuge, we have ultra centrifuge. So there are several types of. Now, if we talk about the application of centrifuge, we have its application in sugar industry, and we have several applications in bioprocess industry. In sugar industry, centrifugation is used for this sugar industry we are talking. It is used for removal of the crystals which have been formed from the sugarcane juice. And in our bioprocesses, we have bioseparation, the removal of cellular elements from blood to get cell-free serum or plasma. Nowadays, you must be knowing that because of our pandemic, there was one way of treatment, and that is plasma treatment. In fact, those who are infected by the coronavirus, body has its own defense mechanism, and they develop some kind of antigens or antibodies. And those who have already been affected, they get some kind of antigens and antibody in their body. So the medical science tries to extract those antigens and antibodies which have been formed in somebody's body, and it is being injected in a person who is suffering from COVID-19 disease. And there it helps in removal. Although recently I got the news that at some places, even WHO says it is not very effective. But in Jaipur Medical College, doctors are still saying that it is very effective, plasma treatment. So it has, again, centrifugation is used here for separation of serum or plasma. Serum is also used for lots of tests of blood. So for that, we use some kind of centrifuge here. Protein precipitate are separated from analytical samples. Macromolecules such as DNA, RNA, proteins or lipids, again, centrifuge is used. Our COVID test also depends on that, what they say, RT-PCR, reverse transcriptase. So they use this DNA, RNA, and they have to be separated from blood. One of them is used for this, okay? And again, centrifuge is helping here out. And then we have PCB, which is percent red blood count determination hematology. Hematology is basically a science of studies of blood. So PCB determination is also done using centrifugation. Then we have evaporation. Those materials which are not thermally sensitive, we can go for evaporation. And in several chemical industries, several process industries, evaporation is being followed. We will discuss about the applications of solid liquid separation using thermal energy. We use thermal energy. And as I said, thermal energy is little more costlier because we have to, and country like India, which is already not very self-sufficient in case of energy, its energy demands. So our attempt is to avoid evaporation, means use the other 2 or 3 processes wherever it is possible. Okay, when we find that the solids are solution form, they cannot be separated, we go for evaporation. Because in that case, we have to resort to evaporation. In the process industry, evaporation process is to concentrate a solution of a non-volatile solute, or to separate a volatile solvent from a non-volatile solute by vaporizing and removing part of the solvent, which may be mostly water. Maybe, of course, we can use some, we may have some organic solvents also, but in that case, the temperature range will be lower. And in case of water, the temperature, of course, goes beyond 100 degrees, because our boiling takes place at 100 degrees Celsius. And if solids are present in solute form, then temperature goes further high, the boiling point goes further high. And in an evaporation process, the liquid solution is usually heated to boiling by steam, as I said. Mostly our heating medium is steam. Now, when we talk about the application of evaporators, we have applications in pulp and paper industry where long tube, vertical, multiple effect evaporators are used. Again, here it is used for concentrating black liquor from around 12% of solids to say 50% or 55% of total solids. For that, long tube vertical evaporators are being used. And you know, MEE, multiple effect evaporation, basically gives us the chance or an opportunity to increase the steam economy. That means more, we get more evaporation from lesser amount of steam applied. So for that, we use multiple effect evaporators. In sugar industry, we have short tube vertical multiple effect evaporators. In pulp and paper industry, generally, in MEE or multiple effect evaporators, we have 5 stages or sometimes 6 stages also. In sugar industry, it is mostly 3 stages, and short tube vertical evaporators are used. Again, here it is used for concentrating the sugar solution, sugarcane solution, sugarcane juice, which has been extracted from sugarcane before getting into crystallization pan. So it is being concentrated using this. In salt industry, short tube vertical, again, multiple effect evaporators are there. This is similar to pulp and paper industry. Salt industry, as you know, we all use salt, Tata Namak, and you must have heard that advertisement also, which says that multiple effect evaporators are basically used, and for that saline water is used. Sea water may be used for increasing the concentration of salt solution. For that, the multiple effect evaporators are used. In dye industry, we use evaporators. We use for pickle liquid. Pickle liquid are basically metal cleaning. This pickle is not the pickle which we eat. This is pickle for metal cleaning. And we have plating bath liquid that is also concentrated using evaporation, electroplating. You know, electroplating wastes are very dangerous and very problematic if we use chromium plating, because chromium is very common and hexavalent chromium is very toxic. And so the sludge which is generated from this has to be treated very carefully because it is carcinogenic. So again, for concentrating, we use evaporators. Then we have sodium sulfate industry, again for evaporation. We have dairy industry for boiling of milk. You know, once we get the milk, it has to be pasteurized. And for pasteurization, the temperature has to be increased. For increasing temperature, increasing concentration, we use evaporation. Of course, for increasing temperature, we use heat exchangers. And for increasing the concentration, we use multiple effect. In food industry, of course, from dairy industry, milk, from milk, we get milk powder also. So milk has to be concentrated before to form milk powder. And for that, we use evaporators. In food industry, for concentrating the fruit juice, we can use, and in other, there may be several other applications in food industry. Then in glycerin also, we use these evaporators for increasing the concentration sometimes. When we talk about the types of evaporators, The simplest is evaporating pan. Of course, sometimes it may be open pan, and sometimes it may be vacuum pan. Like in sugar industry, they use vacuum pan for concentrating their sugarcane solution before crystallization. And there may be types with natural circulation evaporators, we have forced circulation evaporators, we have climbing film evaporators, we have falling film evaporators. They are all basically vertical tube evaporators in which we are using. Of course, natural or forced circulation can be on horizontal type also, but they are mostly falling film or climbing film are mostly used in vertical evaporators. Then we have short tube vertical evaporator, long tube vertical evaporator, which we talked about, multiple effect evaporator. We discussed about enhanced steam economy, and then plate type evaporator. Of course, plate something missed here. Actually, plate type heat exchangers are there. I have not seen plate type evaporator there. So leave this point. Then distillation. As I said, for miscible liquids, we go for distillation and we separate them on the basis of difference in their relative volatilities. So we use different boiling point. They have different boiling points, and we use. So for miscible liquids, distillation is a process of separating the component of substances from liquid mixture by selective evaporation and condensation. Of course. Then we have different types of distillation process, but before I must discuss about the applications of distillation. Distillation is very common in chemical industries and organic chemical industries also. And there are distillation process. In bioprocess industry also, we have distillations. When we talk about organic chemicals, separation of say mixture of acetone and ethanol, we can go for this. And then if we have this broth for forming ethanol, we go for distillation. That's the usual process of producing ethanol from fermentation process. Then if we talk about the types of distillation, we have simple distillation, we have vacuum distillation, we have steam distillation, we have fractional distillation. All the distillation processes have different applications. Let us talk about them. Simple distillation, as I said, ethanol from molasses fermentation. Then refining of crude is very common. All our petrol we are getting or diesel which we are getting is because of distillation only. And that is refining of crude. We have two types of distillation columns. You all know atmospheric distillation unit, that is VDU. So then we have purification of organic solvent. As I said, if some other components are present, then we can go for distillation for purification of organic solvent. And then purification of drug, also distillation is being followed. Vacuum distillation, of course, we go when we want to carry out it at a lower temperature. Two purposes may be there. One is that material may be thermally sensitive, then we go for vacuum distillation because then distillation is carried out at a lower temperature. Second is it also saves basically thermal energy because we don't have to go for higher temperature. So in refining of crude, I said in second stage we can go for vacuum distillation. So there it is being used. And extracts or crude drug production is also done from using vacuum distillation. The next is steam distillation. Steam distillation is very common for isolation of essential oils. All kinds of fragrances, all kinds of essential oils which we are getting is through steam distillation. And you know there is a big Rampur Kannauj. Kannauj is very common for producing whether it is all kinds of fragrances. And you know France, which is the biggest name in all kinds of fragrances, perfumes, isn't it? they also depend on our country. Lots of essential oils are exported from India also. And then petroleum refining, steam distillation, there also it is used. And separation of fatty acid from mixtures, again, steam distillation is being used. Again, steam is used as a carrier for taking the vapors. So at lower temperature, we are able to distill them out. So thermally sensitive materials are not degraded or not, say, decomposed. So steam distillation is that way very helpful. Then we have fractional distillation. In fractional distillation, we have petroleum refining. Petroleum refining has fractional distillation. And again, separation of acetone from water, we have to go for fractional distillation. Now, that was all about our normal separation techniques. Okay. One thing I missed when we talk about centrifugation, I told that it is in liquid mixture we use centrifuge. For gas solid mixtures, we use that called cyclone separators. They also use centrifugal force. So for using centrifugal force for removal of solid particles suspended in gas, we use cyclone separators. So that is because basically it is a fluid solid separation process. Now coming again back to advanced or novel separation processes. These separation processes, those are not conventional and routine, which are not routine, fall under this category. Therefore, some of the equilibrium and rate separation processes are finding place in this novel separation processes. So all kinds of membrane processes and some other processes like membrane-based separation processes, we will discuss about them in a little more detail. Then we have supercritical fluid extraction, which is also very common for maintaining the flavor of something. SCFE is quite used. And then chromatographic separation processes are there. And then we have electric field assisted separation process. Of course, in liquid, when we talk about that, we have electrodialysis. And when we talk about the gas solid mixtures, we have ESPs, electrostatic precipitators. There we use again electric field assisted separation for particles which are suspended in gas. And you know, electrostatic precipitators are so effective for very fine particles which could not be removed from gravity separation or centrifugal separation, as I said, cyclone separators. Then there are third also when we use liquid somewhere, that is scrubbers. Electrostatic precipitators are very effective for sub-micron size particles removal. That should be very clear. Of course, it is expensive because it employs very high voltage. Electrostatic precipitators employ a voltage of 50 to 60 kilovolts, which are very high. 440 volts, when in some pole, if you see electric pole, they put some kind of sign, danger sign, and this process uses a voltage drop of 50 kilovolt, 50,000 kilovolt, or 60,000 kilovolt. And this process has miniaturized now, and it has come to homes also for making dust-free homes, because those who are suffering from problems like asthma, respiratory disease, suspended particulates are very problematic to them. So for have a clean house, we can go for electrostatic precipitators, because electrostatic precipitators are now available in small size also. Earlier it was a very big system and it was used for only, say, thermal power plants or other furnaces where lots of dust was being generated, fine dust was generated. Now that has been miniaturized. Of course, the voltage has not decreased. Voltage application is still 25 to 30 kilovolt. And of course, that has come into being in around late 1800th century. So in the beginning of 1900th century, electrostatic precipitators came for industries in the beginning, and now for last 1 or 2 decades, they are available in small sizes also. In our homes, they can be attached to our air conditioners also. Of course, cost figures I do not know, but they provide you very clean air because fine dusts are being removed there. That electric field assisted separation process. Then we have ion exchange processes. Ion exchange process we use for, again, liquid, for water treatment, and other applications are also there. For membrane separation by use of membranes has been increasingly used in chemical and bioprocess industry. Again, I must tell you that nature also uses membranes for separation. Our own body has got several kinds of biomembranes, starting from our skin, because membrane means something which permits some of the things but excludes some other molecules. So our skin is also semi-permeable. It allows some things to pass and some it does not allow. Same way our intestines. Our intestines are also membranes. They also allow some of the things to pass, some of the things are stopped. So we have several applications in our body. You know, our kidney is also membrane based on dialysis. So God has used membranes very effectively. And you know, there is a saying that anything can be separated if you have a right kind of membrane. We must have a right kind of membrane to separate any mixture. You know, nowadays membranes are used for gas separations also. Earlier they were used for removal of colors, say fine solids, even hardness. They are used for gas separation. Selective membranes are being prepared, which remove selective items. Same way, we have ion selective membranes. Ions have different size because on the base of size these membranes work. In membrane separation, the membrane acts as a semi-permeable barrier which only allows for certain molecules to pass through it, which we discussed. Then types of membrane separation processes. We have microfiltration, which is most the coarser. Then we go for a finer, which is ultrafiltration, then nanofiltration, then reverse osmosis, then electrodialysis. If we go from top to down, the size, pore opening size are decreasing. So we can remove smaller particles with, when we go down. This is a diagram which shows the 4 kinds of membranes. You can see the microfiltration membrane can separate suspended solids, high molecular weight species, especially crypto, Giardia, microorganism, bacteria. Then UF can remove macromolecules, colloids, virus. Of course, some of the virus may pass through also because they have a size very, some of them may pass. So it is not 100% effective for removal of virus. Then proteins can be removed, pectins can be removed. NF, nanofiltration membrane for small molecules, polyvalent ions like calcium and magnesium. Of course, the monovalent ions pass through nanofiltration membranes. So selectively we can remove the polyvalent ions using nanofiltration membranes. Of course, in common use they are not there. We use microfiltration membranes, we use ultrafiltration membranes in water. We use RO very commonly, but NF is not very common, but it is very useful. In fact, many of the jobs which we are doing through RO can also be done through nanofiltration membranes. Of course, then in RO we have salts, we have ions, we have color, we have low molecular solids, weight species. They all can be removed. Even hardness can be removed using this RO membranes. So for microfiltration membrane, we have pore sizes 0.01 to 12 micron, capable of removing suspended solids, bacteria. So the microfiltration membrane is used for primary water treatment. As you said, we all have water purifiers in our house. So the first removal is done through a normal filter, mechanical filter. Then we use microfiltration for removing suspended solids. Some of the bacteria can be removed, not all bacteria. And then the concentrate requires periodic removal of cleaning to prevent the eventual plugging of membrane feed vessels. So all membranes need to be cleaned because of clogging or because of fouling of membrane. The pressure difference which is applied is approximately 10 to 500 kilopascal. This is a diagram which shows this process. Then we have ultrafiltration membrane. Ultrafiltration membrane is used for the separation of macromolecules, that is polymers such as proteins, with molecular weights 1,000 to 50,000. Of course, the subsequent membranes basically work on their cut sizes of this molecular weight. Molecular weight cutoff, they call it MWCO. They have different sizes, different molecular weights which can be removed, because increasing molecular weights increases the size of molecules. It is a high pressure membrane process and it uses up to 150 psi, around 10 bar. And molecular weight of particles may be 1,000 to how much? 1 lakh. Here it is only 50,000 is written. Okay. And then, so it may go for 1 lakh also. And then pore size is 20 to 1,000 angstrom unit. That means this is another size. This figure has been taken from some other book, but because one cannot say exact size, but there may be some over. It says 0.005 micron to 0.1 micron size. Pressure needed for this filtration, ultrafiltration, is 6 to 8 atmospheric pressure. And applications are filtration of protein, nucleic acid, red blood cells, polymers, and for water purification they are also used, which we are talking. Then ultrafiltration continued. This is a figure which shows basically cell and tubular and flat sheet hollow fiber. These are the different types of membranes which configuration in which they are available. Then advantages of ultrafiltration. There are some advantages, there are some disadvantages. Let us talk about the gentle and non-destructive. Gentle means it uses lesser pressure than RO membrane. Low hydrostatic pressures are required. Low temperature operation is possible in this. Constant pH and ionic strength may be maintained if required. Because in RO, pH changes because of buffering is disturbed. Some of the ions are removed, so the pH changes. Here they say for constant pH we can use it. Because ions cannot be separated using this membrane. So that becomes an advantage here. Simultaneous concentration and purification can be achieved using this membrane, and process is economical. For enzymes, little effect on the bioactivity of the protein molecules, okay, because ions are not removed again. High recovery rates up to 99.9%, because in RO, of course, it is comparing with RO and NF, because in RO the rejection rates are higher because it removes other things also. All membrane process develop rejects also, like from ultrafiltration, nanofiltration, and this reverse osmosis membrane. And rapid processing time, it does not take much time. Disadvantages, if we talk, high concentration is a problem. When we are dealing with very high concentration, then we have to have pre-filter, like microfiltration should be there. Shear damage can occur. If we use very high pressure, so shear damage can occur sometimes if particles have, if they are sharp, they are abrasive, this can happen. And for enzymes, rapid clogging of the membrane. In case of enzymes, clogging is very fast. And for viscous solutions, decrease of flow rates and prolonged process time. So, of course, we must know where we should apply it. And after this, we will talk about RO membrane, and I will, after that, nanomembranes are there. We will have some comparison, we will discuss about that. Then nanofiltration, it allows monovalent ions such as sodium or potassium to pass, but reject a high proportion of divalent ions such as calcium and magnesium. This is an advantageous process. In RO, we have lots of reject, in which all salts are present. So for or even ions. So for you can say speciation of ions, we can use this nanofiltration membrane. So reject can be filtered using nanofiltration, and we can separate out monovalent ions and divalent ions, and you can understand it has its commercial value. If we have elements or these salts in pure form, they derive much more commercial value than when they are in mixed form, because pure material fetches more price in market. So that can be, it can be applied there, because it has not been applied for that purpose. I was just suggesting it actually. Pore size is 0.01 to 0.01 microns, and molecular weight of particles should be greater than 300 for removal, and pressure difference is 10 to 20 bar, can operate at much lower and passes some of the inorganic salts due to larger pore size. Of course, monovalent ions can pass through, which we have understood here. And applications are removal of color, vitamins, hormones, and antibiotics used when low molecular weight solutes such as inorganic salts, small organic molecules, glucose or sucrose have to be separated. This is again a schematic diagram of nanofiltration. It is just similar to what we saw earlier. Then we have reverse osmosis. Reverse osmosis is a very common name. We are listening it very commonly in our water treatment. We will discuss about that, because water is used by all of us, and it is one of the commodities which is creating most of the disease also. There are several waterborne diseases. We will talk about it because it is a time we can discuss here. Osmosis as a natural phenomenon is the flow of water molecules through a semi-permeable membrane from low concentration side to high solute concentration side of the membrane. Flow of water, flow of liquid. It may be water, it may be any other molecule, liquid molecule. Reverse osmosis is just opposite to that. It uses very high pressure to force the flow of solvent, say water, in the reverse direction of osmotic pressure. Normally from dilute solution to concentrated solution, liquid flows because of osmosis, if a semi-permeable membrane is in between. But if we use reverse osmosis, we apply a pressure so that the solute is not allowed to pass through, and basically solvent only can pass, because the membrane does not allow the solute to pass because of size exclusion. So the reverse osmosis has got applications in water purification, sterilization, dewatering, and the separation of components in a mixture, small molecules and ions. Reverse osmosis, if we talk about its characteristic, reverse osmosis is used for the separation of very small molecules like color molecules, hardness, sulfate ions, nitrate ions, sodium ions, and other ions. Molecular weight of particles is only CWPO, I said molecular weight, sorry, MWCO, molecular weight cutoff is this. And pore size is less than 2 nanometer. In some other book, as I said, which is very standard, 0.001 to 0.00001 to 0.001 micron. This is the size, operating size range. And pressure is 15 to 60 atmosphere. Is very high. You can understand. It is almost 15 to 60 kg per centimeter square. If we talk about kg per centimeter square. Okay. This is a diagram of osmosis, reverse osmosis. You can see this. Just a minute. Yeah. We can see this. It's just a diagram. We can see it. I wanted to discuss one thing about in water purification. Lots of companies, most of the companies are using reverse osmosis membranes. And you know, whenever you go outside, as a matter of fact, we ask them, RO water hai ya nahi hai? If they say that it is RO water, we are very satisfied. We are very comfortable. We feel that we are not going to fall prey to any disease. So, yeah, this is true also in some way or the other. But one thing I must tell you, in our own household, we should avoid reverse osmosis units if our water supply does not contain contaminants in very high concentration like fluorides and other. Because if we are using RO, all the minerals are being removed. In addition to being a very expensive process as compared to ultrafiltration membranes, because ultrafiltration membranes need very small amount of pressure as compared to the, you can see here it is 15 to 60 atmosphere. And if we see here, in case of ultrafiltration, the pressure is 6 to 8 atmosphere only. So you can understand very high. Here minimum is 15, there only 6 to 8. So that needs much lesser energy, lesser power, lesser cost, okay? And the membrane is also need to be so strong that it can withstand this much pressure. So more expensive than ultrafiltration membranes. So what I'm saying is we are losing on account of RO is that all the minerals are leached out, are being separated out from the water. And when they are separated out, then we need certain amount of minerals in our water. So mineral waters which were coming, they were added minerals. And the packaged water which is coming into market, because two categories of bottled water are coming. One is called packaged water. Packaged water is only that which has cleaned the water and supplied you. So mostly they are using RO plant and they supply as such. Whereas mineral waters contain minerals also. And you know, for our growth and for balanced supply of nutrients, we need to have minerals in our food intake. And lots of minerals go through water also, because with passing time, we all follow a regime in which the physical efforts, physical exercises are getting lesser and lesser. And so our food intake is also decreasing very fast. So food intake is decreasing means minerals are also, because minerals are coming through our food also, in our vegetables and other things also. So water is one of the source of minerals to our body. When we are devoid of minerals, we face several problems in our whole day life. So my only request is that whenever if we can suffice with this ultrafiltration process, we should not go for reverse osmosis. Reverse osmosis is needed only when hardness is very high. Say, in fact, I tell you, the dissolved solid permissible limit in our drinking water standards is 500 milligram per liter or 500 ppm. Yes, this is the permissible limit, but up to 1000, it does not create any problem to us. Of course, if we have higher amount, then it may create some difficulties to us, but up to 1000 there is no problem. So we should see how much dissolved solids are present in our intake water and decide as to reverse osmosis, should we go or not. Number two is, since reverse osmosis removes all kinds of ions, even those which are buffering. See, our water has around 7 pH, but when we remove all kinds of these minerals or all ions, calcium, magnesium, and those, then what happens is the pH comes down, and it may come down even up to 5.5 or so. And as a tradition, the water needs little alkaline water, little alkalines. Its pH should be 7 or little more than 7. It should not be less than 7 actually. So that's why I was saying that if we do not have a water which has very high amount of dissolved solids or say contaminants like fluorides, etc., then we should go for. Even then, there also you must have seen some water purifiers are coming, which have got their own that what they call mineral control. In fact, 2 streams they are using, 3 streams. They use. I can give you example like Kent is giving, and some other manufacturers must also be producing that kind of see, because when the pH goes down, the taste of water also changes. It becomes little more sharper in taste, more sharp taste it gives. So to maintain that, they ask you they tell you that test the water, and accordingly it sets the RO limit as to how much RO water has to be added and how much water is to be taken from either UV unit or from UF unit. That's what they do. So I stop here only this point. Let us go further. Electrodialysis. As we are saying, the charge assisted process, where electric field assisted process, electrodialysis is such. ED is very common in desalination of water. Especially in case of brackish water. Brackish water contains salts to the tune of say 20,000 ppm or so, and our sea water contains this salts to the tune of say 35,000 milligram per liter or ppm. So electrodialysis is very common because some of the areas of Rajasthan, Haryana, or maybe some other parts of our country, they have brackish water in our groundwater. So for that, electrodialysis is quite common process. There is a lab in Jodhpur called DL, Defense Lab Jodhpur. They have done lots of work on electrodialysis, and they have made electrodialysis units which are mobile, which are being mounted on trucks, and they go to some areas like Badmer and those where groundwater was brackish in nature and surface water was not available. So they were supplying water after treating with electrodialysis units. They were visiting, say, this job was, since it's a part of defense lab, so some of the job was being done by BSF or army people also, because it is, of course, BSF is a part of Ministry of Home Affairs, and army is part of Ministry of Defense. DL is a part of Ministry of Defense, of course, because they come under DRDO. So they were supplying water, say once a week or twice a week in those areas. They were taking their mobile vans there and they were giving this service. So ED process, a semi-permeable barrier allows passage of either positively charged ions, cations, or negatively charged ions or anions, while excluding passage of ions of the opposite charge. So basically it has semi-permeable membranes, ion selective membranes, and alternatively they are placed in a chamber. So each chamber gives you clean water or say salted water, because ions are not allowed in that clean water zone because of the ion selective membranes. These semi-permeable barriers are commonly known as ion exchange, ion dialysis membranes. Pore size is less than 2 nanometer and application is salt removal from backwards. Electrodialysis has other uses also, because you know dialysis is the process which our kidneys follow. God has also given you dialysis process. Then we have supercritical fluid extraction. Supercritical fluid extraction is the process of separating one component, the extractant, from the another, the matrix, using supercritical fluids as the extracting solvent. Extraction is usually from a solid, but can also be from liquids. Carbon dioxide is the most used supercritical fluid, sometimes modified by co-solvents such as ethanol or methanol. Application in extraction of high-value compounds from food and natural products. In heavy metals recovery, enantiomeric resolution of drug delivery, and this. So, in fact, supercritical fluid extraction is used for even coffee extraction also. Actually, other processes, when we don't use supercritical fluid extraction, in that case, the taste changes because organic substances, food substances are thermally sensitive. So, because of the degradation, in that case, in supercritical fluid extraction, the quality of or the degradation does not take place. So the flavor or the taste of the material remains as such if you extract from one place to the other. In coffee, you know, instant coffee, we get from those coffee seeds, right? Tea has been made instant, but not like coffee. No tea powder has come which can give you instant. I think nowadays they are giving you blended sugar and milk powder together, and there is instant tea also. Nowadays they have made, I think. Then process details of fluid exchange. The liquid is pumped to a heating zone where it is heated to supercritical conditions. It then passes into the extraction vessel where it rapidly diffuses into the solid matrix and dissolves the material to be extracted. They swept from the extraction cell into a separator at lower pressure, and the extracted materials settles out. The CO2 can then be cooled, recompressed, recycled, or discharged to atmosphere. I said you some food products are extracted from using this process, and beauty of this process is that the taste or flavor is not lost. It basically avoids degradation of materials. Then we have chromatographic separation processes. Chromatography is an extremely powerful analytical tool. You know, in the beginning we had paper chromatography, and then several forms of chromatography is available today. Powerful analytical tool for separating and analyzing complex mixture. Today, chromatography is the basis of several analytical procedures. You know, HPLC, GLC, liquid chromatograph, gas chromatograph, ion chromatograph, whatnot. All those are based on chromatography. And this journey is going forward and forward. Lots of standardized analytical procedures have been developed. You know, for finding out pesticides, for analyzing pesticides presence in water or any other things, we go for this GC. So this is standardized. So if you say application to separate colors in a dye, to separate pigments from natural colors, to separate drugs from the separation process, and it has become a handy tool of analysis for many components, many compounds. If we talk of types of chromatography, we have paper chromatography, which was the most beginning. It started with this. Then column chromatography. We use column chromatography in both GC and LC. Then we have thin layer chromatography, TLC, gas chromatography, ion exchange chromatography based on charge. We have gel filtration chromatography based on size and shape. It basically separates on the basis of size and shape. Ion exchange chromatography, it separates on the basis of charge. And then hydrophobic interaction chromatography, HIC, based on degree of hydrophobicity. And then we have affinity chromatography based on ability to bind specific ligands. So when we talk about paper chromatography is a liquid partition chromatography. In paper chromatography, the end of paper is dipped. You all know very well about paper chromatography. It is the most oldest technique, so let us not go in detail in this. Again, it is discussing about paper chromatography. Organic components of the solvent binds continues migrating, thus forming the mobile phase. Application can also be used for the separation of a wide variety of materials like amino acids, oligosaccharides, glycosides, purines, pyrimidines, steroids, vitamins, and alkaloids like penicillin, tetracycline, and streptomycin. So several applications are there. You can understand. We can use very simple something. It all depends on our ingenuity. Then column chromatography, as I said, column chromatography is quite commonly used in our liquid chromatographs and gas chromatographs. The stationary, there is a mobile phase, there is a stationary phase. The column or packing is a stationary phase, and there is a mobile phase, which may be a liquid mostly in case of liquid chromatograph, and it may be gas in case of gas chromatographs. Stationary phase may be pure silica or polymer, or may be coated onto chemically bonded support materials. Basically, this elution time of these packed beds are different for different components of a mixture, and this elution time basically becomes the basis of separation of or basis of analysis for different components in a mixture. So depending on whether the mobile phase is liquid is known as gas chromatography or liquid chromatography. When the stationary phase in liquid chromatographs consists of a small diameter particles, the technique is called high performance liquid chromatography. In that case, basically high performance liquid chromatography is also high pressure liquid chromatograph. In that case, we use high pressures, and the mobile phase, the liquid which are used are very pure, highly pure. They call it HPLC grade. They need to have a very high level of purity for analysis. Then we have TLC, thin layer chromatography. It is also an old technique, but quite commonly used in drugs and other things. Stationary phase consists of thin layer of adsorbent material, usually silica gel, aluminum oxide, or cellulose immobilized material. Flat carrier sheet. Liquid phase consists of a solution to be separated, which is dissolved in an appropriate solvent and is drawn up the plate by a capillary action, separating the solution based on polarity of the compound. So applications are determination of pigments a plant contains, detection of pesticides or insecticides in food, identifying compounds present in a given substance, monitoring organic reaction. Although depending on their result, the their resolution or their, what I call it, their accuracy, different methods are used in chromatography. These are the steps of TLC. Then we have gas chromatograph, very common. I said gas chromatograph is a very standard equipment for determining the amount of pesticides present in say in water or any other thing. You must be remembering that many years back, pesticides were found in these cold drinks. Of course, for that we have to go for chromatography only for determining the presence of pesticides and their amount. Gas mobile phase is used to pass a mixture of volatile solutes through a column containing the stationary phase. That was liquid chromatograph also, of course, for when we use water. The mobile phase, often referred to as carrier gas, is typically an inert gas such as nitrogen, helium, or argon. Solute separation is based on relative differences in the solutes, vapor pressures, and interactions with the stationary phase. As I said, the elution time is very important. And after elution, we have different kinds of detectors. For different compounds, we need different kinds of detectors. You know, we have thermal conductivity detector, we have UV detector, some 3-4 kinds of detectors are there for in chromatographs for detecting substances, because that detector must be there for finding the presence of that, and the graph, the area covered by that becomes the basis for finding out the amount which is present of that compound. Solute separation is based on relative differences in solutes. This we have talked. Thus, more volatile solute elutes from the column. And as I said, the elution time becomes the basis of separation of the compounds, mixture compounds. Gas chromatography, the column effluent carries separated solutes to detector in order of their elution. Solutes are identified qualitatively by their retention times. Peak size is proportional to the amount of solute detected and is used to quantify it. As I said, chromatogram that becomes, and peak size, of course, higher the peak, more the area, that tells you the amount of that compound present in the mixture. Mobile phase supply, flow controller, injector, columns, detector, then waste. There is a computer controller and then integrated recorder from this side. So this is a process of GC, modern GC that has been shown here. Then we have ion exchange chromatography. Ion exchange chromatography is a process that allows the separation of ions and polar molecules based on their charge. Ion exchange chromatography can be divided into 2 different subtypes. Cation exchange chromatography, for positively charged molecules, they are attracted to a negatively charged molecule. And ion exchange chromatography, in that case, negatively charged molecules are attracted to a positively charged molecule. The application, if we talk of applications in downstream processing, we have applications of ion exchange chromatography. Downstream processing of bioprocess industries, because downstream processing is there in petroleum industry also. There also we are dealing with organic substances, so there also it can be used. But since we are talking about we are discussing more about your department, the department which is running this sort of course is basically biotechnology department. So I'm focusing more on bioprocesses. Of course, other processes are also not left as. Then protein purification and water analysis and quality control. Basically, I'm emphasizing more on bioprocesses. So this is the principle of ion exchange chromatography. In this case, this is the positively charged bead. Of course, this is molecule. Again, 2 different this similar charge particles will be attracted, and the others will, the same charge will repel each other. So that is being shown here. Then we have gel filtration chromatography, also known as size exclusion chromatography or molecular sieving. The principle is size exclusion chromatography is the separation technique based on molecular size of the feature of STC is its gentle, non-adsorptive, enabling high retention of biomolecular activity. Larger analytes that are completely excluded from the pores will pass through the interstitial space between the particles and will appear first in the eluate. And smaller analytes will be distributed between the mobile phase inside and outside the particles and will therefore pass through the column at a slower rate, hence appearing last in the eluate. So this is about gel filtration chromatography in very short. When organic solvent is used as mobile phase, the process is known as gel permeation chromatography. Applications are separate compounds such as small molecules, proteins, polysaccharides, and nucleic acids when in aqueous solution. When they are present in aqueous solution, they can be separated using gel filtration chromatography. This is again a diagram of that. It shows that larger molecules are coming, finding the interstitial space. Okay, and these are the porous particles. The smaller molecules will go inside this and they will come out. This is the way the process has been shown. Operation in size exclusion. Operation in size exclusion. This is void volume, of course. It shows void volume, sum of internal volume. This is a diagram just for size exclusion, because this gel permeation, gel filtration chromatography is called size exclusion also. Basically, it's based on size only. Then we have affinity chromatography. It is a method of separating a mixture of proteins or nucleic acid by specific interactions of those molecules with a component called ligand. This is again a new chromatography. New means relatively new. Maybe for many years it is there. Ligand is immobilized on a support, and for antibody isolation, an antigen or hapten may be used as ligand. Again, we were discussing about antibodies, antigens, which are nature's gift to our body to fight against disease such as corona infection or any other virus infection disease, right? Not only virus, bacterial disease also. That's a gift of God to us, and we use for this, as we were discussing about this, for plasma technique. It is one of the most powerful chromatographic methods for purification of a specific molecules or a group of molecules from complex mixtures. Okay, if an enzyme is to be purified, a substrate, analog, inhibitor, cofactor, or effector may be used as the immobilized ligand. Affinity chromatography applications are, it is used for isolation and purification of all biological macromolecules. It is used to purify nucleic acid, antibodies, enzymes, etc. So maybe it might be, I am not sure whether they are using it or not, whether antibodies which are obtained from someone's body are being purified before being injected to other. I'm not sure, but maybe it can be used. One needs to study more about this to know, because behind such things we have lots of opportunities of research. So we must see that those things very clearly. We should read behind those things. As I said, I'm not sure whether they are using affinity chromatography for purifying the antibodies or antigen which they are obtaining from someone else's body. That's a point to be studied. Then principle of affinity chromatography. It is used for isolate this. We have already talked. It is used for purify nucleic acid. This is also we have talked. This is how it works. It's a diagram just to show that. This is operation in affinity chromatography. This is again a diagram. This shows how it works. Then partition chromatography. Separation on the stationary phase occurs by partition due to differences in partition coefficients used for liquid or liquid gas chromatography. Here the molecules get preferential separation in between two phases. That is, both stationary phase and mobile phase are liquid in nature. Polar molecules get partitioned into polar phase and vice versa. Applications of partition chromatography of natural extracts and biological matrices is being done using partition chromatography. Fractionation of complex crude extracts from, for example, petroleum fractions, we use partition chromatography. Determination of water quality, that is to be seen which, I don't know which parameter is being tested of water. Then separation of aroma molecules of wine using partition chromatography, and determination of pesticide residue. This actually not very common in our country. It is more common in Western world. In India, we have mostly IMFL, Indian made foreign liquor, and all those things. Wines are either imported, and I don't think they are produced so much in India right now. But those countries like Britain, particularly Scotland, etc., they produce wine, and other parts of Europe also. I don't have much details on that. This is a diagram of partition chromatography, just to have a pictorial understanding of this. Bioseparations. Now, I just want to ask you, am I audible? Because there is nothing interaction between our, there is no dialogue on that part. We will have question answer at the end, but am I audible? Am I audible?
Yes, sir, you are audible.
Right.
Yes, sir.
Is clear?
Yes, sir. Yes, sir.
Thank you. I'll go for next part, bioseparations. Introduction. Bioseparation follows bioprocessing. You know, any bioprocess we do need to have a separation part. In the beginning, as I said, the cost of product or the demand of product depends on purity of the product, and that is being obtained by separation processes. When we do it for bioprocesses, we call it bioseparation. Bioprocessing can be broadly classified into two categories: reactive bioprocessing and extractive bioprocessing, which we do it. In reactive bioprocessing, bioseparation follows biological reaction. In extractive bioprocessing involves bioseparation. The biological reaction can be fermentation, cell culture, or simply an enzymatic reaction. This is reactive bioprocessing. This is extractive bioprocessing. This block diagram is shown. Upstream processing, biological reaction, then bioseparation. Upstream processing, bioseparation. This is extractive. Bioseparation and purification. This is a very common process where we used to have. This is, we can call it as downstream processing. Like from fermenter, solid liquid separation has to be done here. The product which is coming, supernatant goes this side, cells goes. We may follow here either sedimentation, we may go for centrifugation, depends on the types of cells, types of difference in density or size. The first is mostly centrifugation is being followed. And from cells, we get cell rupture from cell products. And from cell rupture, we get cell debris or the recovery. We do purification obtained from cells. And from supernatants, we do go for recovery, then purification, and we get extracellular products. So extracellular products are present in liquid form, which is going in supernatant, whereas in solid, means cells, we get intracellular products. Downstream processing requirements, maximum recovery of the desired product. The processing equipment must be reliable. Large reductions in volume between the fermentation broth and the final fluid. And a spent broth that can be easily utilized for recycling unused nutrients, because we add lots of nutrients to our broth. It has to be recycled in order to make the process economical. Separation in biotechnology, large scale, organic acids, amino acids, antibiotics. There we use industrial enzymes and single cell SCP is single cell protein. On that day, Misraji was saying that he did research on this. Misraji was my guru actually. He taught me during my bachelor's and master's studies. And small scale diagnostics, we use separation biotechnology. Therapeutics, that means related to pharmaceuticals, treatment using pharmaceuticals, and then research probes and tools. In small scale, that is the applications or separations of applications of separations in biotechnology. Cell separation and broth conditioning. Cell separation, we have settling, flotation, filtration, centrifugation, flocculation and coagulation, and two-phase liquid separations. Broth conditioning, we have conditioning or pre-treatment of the contents of a bioreactor is normally designed to improve subsequent broth handling properties. Flocculation and coagulation. Flocculation, we are very common. Before coagulation, we go for flocculation so that agglomerates can be formed. Because once agglomerates are formed, then the coagulation is more effective. And in coagulation, the suspension of cells by neutralization of their charge. We use some kind of agent which neutralizes the charge. Once charge is neutralized, the suspension settles out. So that is what is coagulation. Basically, if we try to understand coagulation, that if two friends are there, they are in close understanding. If we can add some kind of misunderstanding between them, they will separate out. So coagulation is also same thing. This is just for joke I'm saying, but for understanding we have to understand something. So charge means two persons who have different nature, which are binding. And if somebody comes in between and he or she puts something which become them to repel each other, and then the coagulation happens. Coagulation is separation of liquid and solid part of it. The factors affecting agglomeration: genetic characteristics of cells, surface charge on cells, surface chemistry of cells. Broad components means which other components are present, like glucose, metal ions. Then surface physical characteristics of cells, they are very important, you know. Then time-dependent physiological states of cells, and last, environmental dependent physiological states of those cells. Environmental means the process conditions, temperature and other things, right? pH, temperature and all those things, that is important here. Complexities of flocculation, poorly understood mechanism. Basically, flocculation is not well understood actually, and that's why the control on flocculation is not so good. It's poor control. Unpredictability of fermentation batches. We cannot predict as such between the quality or the type of behavior between fermentation batches. Means broadly we can, but not very fine. Limited applicability to cell debris. It is not, and physical instabilities or shear degradation also. That is another complexity. cell disruption. The choice of method for large scale cell disruption depends on susceptibility of cells to breakage, product stability characteristics, ease of extraction from cell debris, rapidity of the method, and cost of the process. We are talking about the cell disruption. If you remember, we discussed the steps after fermenter, and one of these steps is cell disruption. We use some kind of agitator or any other mechanical device which can disrupt these cell structures. So we have to see our method depends on these things, right? How fast the method is, what is the cost of process, how easily we can extract the cell debris from that disrupted cell products, and again, product stability and characteristics. These all things are very important. This is cell disruption methods. We have different mechanical method, non-mechanical method. For mechanical method, we have homogenizer, we have bead mill. In non-mechanical methods, we have physical heat stock, we have chemical detergent, chemical additives for non-mechanical cell disruption, that is detergents, solvents, sequestrants, and then we may have enzymatic cell disruption also. So these are the different cell disruption methods, and basis of selection or choice depends on the earlier factors which we discussed. Let me have a sip of water. Sorry for disruption. Yeah, cell disruption methods, mechanical and physical cell disruption. We have linear high pressure homogenization, that is homogenizer, solid shear grinding, milling agitation plus abrasives. We have freezer or thawing methods we have, and we have osmotic shock method. These are the different methods which we can use for cell disruption. Cell disruption. Liquid shear means if we use high pressure liquid, high pressure homogenization, that will provide liquid shear. Solid shear, we may have grinding, milling, those things, is abrasive treatment, and we may have very freezer, thawing, freezing and then thawing, that we have. And then ultrasonic disruptions are also there now. Ultrasonic homogenizers are also coming, and then this is osmotic shock. Cell disruption methods. Chemical cell disruption, cationic and anionic detergents may be used like alkali, organic solvents. Enzymatic means lysozyme and related enzymes, where hydrolysis of polysaccharide layer of bacterial cell walls is being done. Lysozyme is basically used for enzymatic hydrolysis of these cells. Of the bacterial cell wall is to be hydrolyzed. Separation of solid and liquid phases. It involves unit operations, settling, flotation, filtration, centrifugation, or coagulation. Settling used in wastewater treatment and alcoholic beverages. Particles or cells settle to the bottom. Flotation, application of gas bubbles to increase the buoyancy of particles. Used in the alcoholic beverage industry and in wastewater treatment, flotation. Cells rise to the surface and get collected due to buoyancy and applied to cells. These are the two processes, settling and flotation. They are being used. We are talking bioseparation, so we are talking about the separation processes which are being used. And then we have filtration. Important factors: properties of filtrate, density and viscosity, nature of solid particles, shape, size and size distribution. Scale of operation dictates type of filtration used, which we discussed. We discussed different types of filtration techniques. So it will depend on the scale of operation. If small scale is there, we can go for plate and frame. If we have large scale, then we have to go for continuous filters, which we discussed earlier. Then there is very important thing called filter aids. Filter aids are basically used for improving the porosity of the filtering medium. When we use some separation through filtration, which is not porous in nature, so it will form a cake on the filter medium, and because it is not porous in nature. So for that purpose, we add some filter aids. Filter aids basically improve the porosity of the cake which is being deposited on the filter medium. So poor porosity of solid require filter aids. Filter aids may be diatomaceous earth. In sugar industry, for filtering sugar juice, the solids which are coming, they are also sometimes gelatinous in nature, very means similar to gelatinous nature. So they use bagasse particles to increase its porosity. Consequences of using filter aids: high voidage. It improves voidage, in fact, increases volume because we have added this also. Absorption of some filtrates because it will have absorption problem. Compressibility and non-recoverable. Moreover, we are adding something. If the material is of commercial value, then we are adding filtering aids, and films cannot be recovered from that mixture. So in sugar industry, bagasse, if you add, the outcome is press mud, and press mud is used as a fertilizer. So there it is not a problem. In some place, some application, if the cake, the solid which are coming, it has commercial value, then it will decrease commercial value because filter aid has also been added to it. Then plate and frame filters. Plates and frame arranged alternatively. We are very clear about plate and filter press. It is very common, right? Filtration of yeast cells from beer after rotary vacuum filter. We use sometimes plate and filter frame. Basically, polishing device here also. In breweries also, it is used there. Then leaf filters types. Pressure and vacuum, both types are there. Pressure leaf filters, vacuum leaf filters. Intermittent batch filters, they are number of leaves, metal frame covered in a fire ring, may be pre-coated with a layer of cellulose fibers. Classification: vertical metal leaf filters, horizontal metal leaf filters, and candle type filters. There are three types maybe there. Then rotary vacuum filtration, application used for filtration of biological suspensions. Performance depends on rotation speed, immersion, pressure drop across filter, solid content of the feedstock, temperature or viscosity of feed, cake resistance or compressibility, and cloth resistance. Then centrifugation, because centrifugation is also very common in bioseparation industry. Mostly utilized at laboratory level for separating biological solids, difficult at industrial scale. Used to remove microorganisms and other similar sized particles from a broth. Essential when filtration is slow and difficult. Then we go for, I had said, when the filtration is slow, we go for centrifugation. Applied to obtain cells or other suspended matters free of filter aids. In this case, we do filter aids. So, as I said, your material, solid material is expensive or it has commercial value, then we can go for centrifugation. Centrifugation, it requires high angular velocity, large radius of centrifuge, large volume, thin cementation layer. Types of centrifuge: we have tubular bowl centrifuge for engine, we have multi-chamber centrifuge in case of baker's yeast. We have basket centrifuge in sugar industry. We have scroll centrifuge in case of sewage, sludge, or enzymes. These are the types, and others are uses. We have drying, purpose of drying, the cost of transport can be reduced, the material easier to handle and package, the material can be more conveniently stored in the dry state. So drying is also followed in bioprocess industry. Drying of microorganism or other products, last stage of manufacturing process, long drying time with low temperature because it is heat sensitive material. Short drying times with high temperatures, generally better, but it depends. We cannot go for thermally sensitive materials. separation requirements, coarse debris removal, centrifugation and filtration, fine particulates depends on concentrating procedures, biomass, extracellular or intracellular products, membrane products, cell wall products, precipitation, salting out. Enzymes may be precipitated and fractionated by salting out using which is harmless to most of the enzymes. Process conditions, high concentration of ammonium sulfate. It is 2 must be down actually. 2 must be subscript. Purity, pH of the temperature control, contacting mode and duration, high capacity centrifuge or membrane process is required for separation. Desalting, okay. The chemicals involved in bioproducts. For solvents, we use ethanol, acetone, acetone, butanol. Organic acids, we use citric acid, lactic acid, butyric acid. Vitamins, we use ascorbic acid, vitamin B12. Nowadays, vitamin B12 is also very important, and ascorbic acid is vitamin C basically. And nowadays in Corona time, doctors say you should take vitamin C, you should remain rich in vitamin C and vitamin D3 for people who have age greater than 40 years. And vitamin B12 is very important for those who have age greater than 55 or so, and particularly when they are vegetarian in nature, because vitamin B is available only through animal sources. So those who are basically vegetarian, they have limited source of vitamin B12, and that is what is that? Basically dairy products mostly, right? So B12 we should be very careful, and it has to be supplemented after the age of 50 or 55, because deficiency of vitamin B12 can cause anything, thyroid dysfunction, it can cause diabetics and many things. So I am not a qualified doctor, I am just hinting. So whatever I am saying, you can check with the doctor, that will be better. So I am not prescribing that you should take, but my feeling is that if you feel some difficulty, you can talk to doctor, because B12 is also necessary for neurological conditions to remain very good. So it is very important, we must know. So amino acids, lysine, phenylalanine, glycine, antibiotics, penicillin, rifampicin, streptomycin. There are several antibiotics, sugars and carbohydrates, glucose, fructose, and lipids, all kinds of fatty acids, nucleic acids, semi-purified proteins, industrial enzymes, egg proteins, milk protein, purified proteins, therapeutic enzymes, monoclonal antibodies, plasma proteins, cells, baker seeds, and crude cellular extracts, yeast extract, soy extract, and hydrolysates. There are some animal tissue and all those things. Application of bioproducts. In industrial chemicals, we have solvents, organic acid, industrial enzymes. Agrochemicals, we have biofertilizers, biopesticides. Biopharmaceuticals, we have antibiotics, hormones, synthetic hormones, monoclonal antibodies, plasma, proteins, vaccines. Food and food additives, we have whey proteins, milk proteins, egg proteins. Nowadays, all those who are making bodybuilding, those who are they want to have a very six-pack ab and all extra proteins. So whey protein is very good for those, milk proteins are very good for those who are vegetarian. But those who are non-vegetarian, agrarian, they can go for egg proteins. So soy protein is again a vegetarian. So, but while taking proteins, one must be very careful, because proteins are to be taken in a very limited quantity. That's very necessary. Otherwise, higher amount of proteins may affect. Then nutraceuticals, we have vitamins, enzymes, coenzymes. Diagnostic products, we have glucose oxidase, peroxidase, HCG. Commodity chemicals, detergent enzymes, insecticides. Then laboratory reagents, bovine serum, albumin, cosmetic products. Importance of bioseparation. Bioproducts is difficult and expensive. Proteins and nucleic acid used as pharmaceutical purification is the limiting factor in the commercialization of bioproduct. Bioseparation costs are substantial in bioprocessing. As I told you in the beginning itself, bioseparation cost is very, that constitutes sometimes 90% of the cost of bioprocessing, because purity of product is very important, as I said. The cost of bioseparation, solvents may cost 15 to 20%, cells may cost 20 to 25%. Crudes, it is a typical figure that may not be hard and fast, because if you add them together, they will become, because they are not additive as such. This is just an idea, basically. It can go up to that, basically. Then basis of separation in bioseparation processes, filtration, membrane separation, centrifugation, density, based on density we have centrifugation, sedimentation, flotation, diffusivity, membrane separation we talked, shape, centrifugation, filtration, sedimentation, polarity, extraction, chromatography, absorption, solubility, extraction, precipitation, crystallization, electrostatic charge, absorption, membrane separation, electrophore, membrane distillation and evaporation. Products and processes of bioseparation. Bioproduct separations of cells from cell culture medium, separation of blood cells from plasma in the manufacture of plasma proteins, removal of bacteria and viruses from protein solutions, separation process, filtration and membrane separation, sedimentation, centrifugation and flotation. Particle separation in liquid medium, bioproducts, fractionation of subcellular organelle. These are applications of basically particle separation in liquid medium. Separation of plasmid DNA from chromosomal DNA, separation of mature cells from young cells. This is all basically particle separation. Process, centrifugation followed by artificially induced gravitational field. This is the process being used for these bioproducts separation. Then particle solute separation in liquid medium, separation of dissolved antibiotics from cells and cell debris present in fermentation process, because antibiotics are prepared by fermentation only. Removal of solvent from solid product, for example, protein concentration enrichment, replacement of solvent from solution by another solvent, that is solvent exchange. The method used for particle solute separation are fundamentally similar to those used for solid liquid separation on account of the fact that the solute remains dissolved in the liquid medium. And the process for all these separations are evaporation and distillation, nanofiltration, adsorption, precipitation. Solute separation, most challenging form of separation, solute separation. For example, separation of serum albumin from other serum proteins. Process is adsorption. Liquid extraction by contacting the solution with an immiscible liquid in which the target solute has high solubility. Liquid extraction very well. And then nanofiltration, ultrafiltration and dialysis membranes are also used for this purpose. And last one is sometimes precipitation can also be used for this purpose. Liquid separation, manufacture of acetone and ethanol. Process is distillation for miscible liquids, decantation for immiscible liquids. This is liquid separation. Purity, production versus process. Low resolution plus high throughput means high productivity. Low resolution means low purity. High resolution means high purity. Whenever our purity is high, our production will be less. Whenever purity is less, we may have higher production. So cell disruption, these are high throughput processes. These are low throughput, ultracentrifugation, chromatography, affinity separation, electrophoresis. These are low throughput, means low production processes. Important factors. While developing a bioseparation process, the following should be taken into consideration. Number one, nature of starting material. For example, cell suspension, a crude protein solution. The initial location of the target product, for example, intracellular, extracellular, embedded in solid materials such as inclusion bodies. The susceptibility to degradation, for example, its pH stability, sensitivity to high shear rates, or exposure to organic solvent. We are basically discussing the important factor while selecting bioseparation process. The desired physical form of the final product, for example, lyophilized powder, sterile solution, or suspension. The quality requirements are, for example, percentage purity, absence of endotoxins or aggregates, and last is process cost and economics. This also is very important in any commercial process. Most important thing, we must see that we have to be cost effective. Important factors: RIP is a conventional process, recovery, isolation, purification, and polishing. This strategy involves use of low resolution techniques, for example, precipitation, filtration, centrifugation, and crystallization. First for recovery, and isolation followed by high resolution techniques such as affinity separations, chromatography, and electrophoresis for purification and polishing. This is how the process of separation is being done in bioindustry. The high throughput, low techniques are first used to significantly reduce the volume and overall concentration of the material being processed. The partially purified products are then further processed by high resolution, low throughput techniques to obtain pure and polished finished products. I am increasing, I'll take a minute or two. Purification and reagent grade monoclonal body. This is the steps which is being given in this. Emerging trends in bioseparation. With the advent of membrane separation processes and other new separations, potential exists for avoiding the conventional drip scheme which I discussed earlier. Membrane processes give high throughput and can be fine-tuned or optimized to give very high selectivity. The use of these new techniques can significantly cut down the number of steps needed for bioseparation. Emerging trends in bioseparation. Some of these new emerging techniques are membrane and monolith chromatography, expanded bed chromatography, high resolution ultrafiltration, and hybrid bioseparations, which I wanted to say you may have your queries. I hope that there may be some questions in your mind.
Okay. Thank you so much, sir, for your highly informative lecture talk, and I'm sure all the delegates have benefited from your words of wisdom. I have a few questions from the delegates in the chat box. With your permission, I can ask a few.
Yeah, definitely.
Yes, sir. Thank you, sir. Ms. Renuka, PhD research scholar, she has put a question. Nanoparticles are difficult to separate from water, even by centrifugation technique. Can we use some other techniques for better removal of nanoparticles from water?
Nanoparticles are really challenging actually. Separation of application of nanoparticles definitely gives us good results, very effective. But separation of nanoparticles is really challenging. We must have, the size is nano. So we have discussed about the advanced separation techniques. We have membranes which are based on their size. And nanoparticles have size in nanometers. We all know very well, right? So while discussing, we can see the RO membranes are fit for removal of them. RO membranes can definitely be used. Of course, as I said it is easier said than being done. It is little challenging, but RO is very commonly used. We use them very well. RO is a very standardized technique. So RO membranes can be used. I hope there may be some other techniques also.
Okay, so I think she has another question. To identify the organic pollutants from the industrial effluent, which separation technique we can employ? We generally use liquid chromatography, But sir, can you please tell if we use liquid chromatography, what is the procedure to find what are the organic pollutants industrial effluent consists of? If we can use other techniques, kindly guide us.
This question is very open actually. When you call industrial pollutants, there are several industries. Every industry has its different pollutants. Because when we are talking about the pollutants, we have to talk about the contaminants we are talking of. As I said, for pesticides, GC is a very standardized technique for determining the presence of pesticides and insecticides. Very common technique. Very effectively it is being used. But there are several compounds which can be determined using spectrophotometer, UV or visible. So it depends which contaminant we are talking of. When we talk industrial effluents have consortium of contaminants. Several things are there. So which to talk of? It's a very open question.
Okay, sir. Then we can go to the next question by Mr. Pankaj Kumar Shrimal. He says, in dyes and intermediate industries, the industries have set up wastewater treatment plants, but treatment of wastewater is still a problem for industries while producing dyes and intermediates like H acid, G salt. The dyes and intermediate gets dissolved in the wastewater, which is not possible to separate by the present methods of wastewater treatment. So is there any other economical technique to overcome this problem?
Yeah, first he said there is no technique, which is not right. Now he is saying what is the economic technique. Simalji, I want to tell you that dyes can be removed and dye intermediates also. But we have to see there are methods, oxidation techniques that can be used for dyes. Yes, for larger scale, they are difficult to apply. We have photocatalysis, we have other techniques, we have reactive adsorption also that can be used for removal of dyes. Yes, they are little more expensive because these compounds are newer means not 1 day or 2 day old, many years old, but earlier pollution removal was not a very primary goal. Nowadays it is very important to mitigate pollution, and wherever dye is produced, lots of pollution, and particularly with azo dyes, they are very toxic in nature. So they can be removed. There are processes for removal of them. Yeah, as far as economics is concerned, for very small industry, it is little difficult. And it is for us to research, find out more cost-effective methods for their treatment. Simaji, you should work on this. You have several clues for that. You can go for that. If you have anything else, please let me know.
Yes, sir. There's another question from Dr. Jalandhar saying that among Western blot and STS page technique, which is better one for the separation of proteins?
Yeah, I couldn't. Two techniques you said. What?
Western blot and SDS page.
Okay, I cannot say. I'm not a hardcore biotechnologist actually, so you may excuse me for this question.
Then there's another question: how surface charge affects the agglomeration of nanoparticles? If point of zero charge is more than 30, then the nanoparticles are stable in water. But if it is less than, then it is unstable. Is it due to agglomeration of nanoparticles?
I couldn't get his exact question. Yeah, point of zero charge, he said, surface charge are important for agglomeration. And there are potentials that what they call it, zeta potential and zeta potential is basically used for agglomeration or say coagulation. So one should see on that count actually. Zeta potential can tell us whether we can separate them or not. We can flocculate them or not. Zeta he should look to, I think, zeta potential of the material.
I think, sir, most of the questions are very well answered, and I hope the delegates must have, they are all benefited for your talk, and you have, thank you once again from all the organizers for sparing valuable time from your very hectic schedule and sharing your expertise with the participants. Thank you, Dr. Vyas. Thank you so much.
Thank you very much.
Thank you, sir. Thank you for giving such an informative
Madam.
Yeah.
Hello.
Thank you, sir.
Yeah. Thank you very much. Yeah.
Sir, I think there is some question from Mr. Prabhat Kumar Swain.
Yeah.
Prabhat ji, are you asking something?
Yes, I am asking.
Yes, please.
Very good presentation, sir. Actually, I put one very small question in YouTube. Maybe you are not attending YouTube. Okay.
Yeah.
Very
Actually, we could accommodate the participants in this Google Meet, so I'm sorry we couldn't see that.
Okay.
You can just put a question there.
Okay, and a small doubt. You have mentioned so many separation process and technique. Which one is actually good for biological samples? I think some question also there. Which one is you are suggesting? Which one is good?
Yeah, it depends on the situation. We have discussed on the basis, what are the basis of selecting a bioseparation tool or bioseparation technique. There are several factors now which we discussed. Cost is one, then in which form we want the product. Several things are there. If you remember the last slide, if you want, I can show that again. There is one slide on that itself.
No, that's okay. I understood. But what people are using popularly in term of cost and efficiency, that you can mention.
Normally, centrifugation is quite common for separation, but important in which form our final product is desired, whether in the powder form or a suspension form or what. It will depend. You have seen two-stage separation processes are there. We have discussed in the presentation itself.
Okay. Thank you very much. And another small one is, can we do polymeric material do separation in affinity chromatography?
I couldn't get your question. Polymeric material?
Can we separate polymeric material in affinity chromatography?
Affinity chromatography. Okay. That is size exclusion. I'll have to see actually answer. You can see two are there. One is gel permeation, gel filtration, and one is that affinity chromatography. Affinity chromatography depends on the charge actually, how they can come together or not. Isn't it? A ligand is used. So that is to be seen. I don't know which polymeric material you are talking of.
Okay. Okay. Thank you very much.
Thank you, Swain Saab.
Thank you very much. Very good. A lot of discussion I have seen your presentation. Thank you, sir.
Yeah.
Actually, I must say that at this moment that sir has covered all the major separation techniques used in chemical as well as biochemical engineering. And as you put the question and the previous question was there, we have actually see that what suits us, our requirement, and based on the various parameters as sir has told, we can decide which technique we can use actually. With these words, I would like to thank our esteemed speaker for today's lecture, Professor R.K. Vyas, for sparing time and giving his valuable time to all the speakers and answering to the queries. Sir, we will keep on interacting with you and need your expertise in future as well. So thank you for joining and guiding us at this occasion. Thank you very much, sir.
Thank you, Bansal sir, for giving this opportunity to talk to you and participants. Thank you very much.
Yes, sir. Thank you, sir.
Thank you, sir.
For the information of the participants, next session will be starting at 3 p.m. by Professor S.K. Kansal. So kindly join by 2:45 for the next session. Thank you all. We close this session now. Thank you.
Thank you.
Very good afternoon, dear delegates. The next session is going to start within 5 minutes. Very good afternoon, Dr. Kansal. Yes, Dr. Bansal is there. Dr. Poonam Chedda is there. Yes, sir, we are not getting your voice. We are not getting any signal, sir. Sir, please make isko mute off. Yes. Sir, your voice is muted. Sir, speaker on, please. Put your speaker on.
Hello. Hello.
Yes, sir. Now we are getting. Yes, sir.
Okay, ma'am. Okay, ma'am. Okay.
Very good afternoon, Professor Kansal.
Thank you, ma'am.
Dr. Bansal is
Good afternoon,
there.
ma'am.
Good afternoon.
afternoon, sir.
Namaskar. Good afternoon,
Good afternoon.
ma'am.
Namaskar, sir. Good
Namaskar,
afternoon and
ma'am.
welcome.
Thank you so much, ma'am. Thank you so much. बंसल साहब नमस्कार.
नमस्कार डॉक्टर साहब.
हाँ जी, कैसे हैं?
वेरी फाइन.
पैंडेमिक पीरियड कैसा है ना, बड़ी मुश्किल चल रही है.
हाँ जी सर.
बड़ा अच्छा लगा. मैं थोड़ा सा लेट तो नहीं है?
नहीं सर, you are on time.
ठीक है जी.
In fact, we normally have around 70 to 80 participants, and we see just 30 are there. So gradually they'll be joining us.
Okay.
Normally, this is the trend we are seeing.
Okay. Good.
Yeah.
Your course is, I think, going very good.
Yes,
Actually-
thank you, sir.
Actually, speakers are very good, and response from the students is participants is nice.
Okay. Okay. Normally, जे ਆਪਾਂ देखिए ਤਾਂ सॉरी हिंदी में ठीक रहेगा ना.
Yeah, we have.
कुछ लोग बाहर के होंगे, कुछ लोग बाहर के होंगे.
Doctor, sir, just I take a minute
Yeah,
because you
please.
started in Punjabi. That's why I want to tell that we have 22 states representation in this course, and 3 to 5 participants are from abroad as well.
Okay, it's very
Yeah.
good. It is unique. I think most of the courses are, whichever I could attend as well as present my some experience. Nobody from the abroad or maybe outside country. कोई candidate there was no candidate.
Yeah.
But you are lucky enough, so it's good to know.
And in fact, initially there were so many participants, and we are screening this lecture live cast on YouTube channel of NIDG official channel.
Yeah.
So many students, many delegates are expected to be there.
Okay. No issue.
Because when we exceed 99 and above, so
Ji.
this Google platform does not accept the further entries.
Okay.
So that may be a reason that only a select number of participants are there in this group. The others may be at YouTube as well.
Definitely, the mass media is there, so anyone can attend if you are streaming live on, YouTube or maybe.
Even Doctor, we are just slowly establishing ourselves into this new technology-driven world, and we have tried various platforms: Zoom, Google, Microsoft, WebEx, and Institute directed us that we should go on Google Meet, because through that we are taking the classes, normal classes, and in case of students, we just go to the YouTube version.
So you have subscribed this. You have taken the subscription.
No, we have not subscribed. We are just going only on what you call free basis.
Free basis.
Every time we think that yes, pandemic is going to end in another 1 month or so, so everybody is delaying on that part. But it is extending, and even in Punjab, we see for last 3-4 days there is a little increase in trend. Delhi, if we see Delhi is going very high.
Delhi is going very fast.
Yeah.
Yeah. At very high pace, they are, the cases are coming.
Yeah. So I think if you are comfortable, we can start with this thing, because
No problem. I am ready.
I request ma'am to kindly introduce the speaker for today's talk, and then
in my view, I think no need, because everybody,
we have speakers from all over India.
That's I was watching. I was going through the list. Indramani Mishra, you could tap him. He's a gem.
Yeah, he was our founder speaker, means first day speaker, and then we started. And yesterday we had
my teacher, Professor Ghatak, is there.
Yeah,
So I
Professor
think
Ghatak was there, and
Yeah,
his talk
yeah.
was very much appreciated. And Dr. Anil Verma we had last day, and he is
Yes.
working on electric vehicles charging platform, and that is Flow. So that is
Okay.
they are at the level of commercialization of that technology for upcoming electric vehicles.
The future is with electric vehicles.
Yeah. So, ma'am, can you introduce the speaker, please? Ma'am, please unmute yourself and then introduce the speaker.
Yes, yes. On behalf of organizing committee, I welcome Professor Sushil Kansal. And Dr. Sushil Kansal is an academician and researcher of international recognition at Dr. S.S. Bhatnagar, University Institute of Chemical Engineering and Technology, Punjab University, Chandigarh. His research areas are environmental science and engineering, biomaterials, advanced oxidation processes, nanotechnology, air pollution, mass transfer, water pollution, and material science. He has published more than 62 research papers in reputed international and national journals. One of his research publication, which was published in 2007, has more than 530 citations. Sir, we heartily congratulate Dr. Kansal for his extraordinary achievement, as his name has been appeared in top percent scientists of world. This prestigious ranking has been released by Stanford University, USA. Sir, I welcome you to deliver the talk.
Thank you so much, ma'am. Before start, I would like to thank the organizers, Professor Ajay Bansal ji, for inviting me, Dr. Renu Bansal, Dr. Faculty of NIT Jalandhar Biotechnology Department and Chemical Engineering, I would say. So thank you, sir. I will speak, from the basics of this industry, so I can give this option to the my participants. Anytime you can interrupt me in between, or you can ask any query on maybe some criticism or maybe some discussion, so I would be happy. So it's it's from my side. You please don't feel any pressure. Wherever you feel that something is not getting clear, so please interrupt me. You can stop me, you can raise your hand, or you can directly ask the question. So thank you very much, ma'am, again, and the organizers, especially Ajay Bansal ji, for giving this chance to discuss some points about this industry with the participants. Thank you. So I am sharing my your presentation. I will be going to off my video. I think it would be better for the continuous operation. I'm sharing my presentation. Please let me know, is it visible to everyone?
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay. It's not coming on my screen.
Doctor, it is visible to us, sir.
Okay, so I can go to my slides. Now it's okay?
Yeah, it is okay for us.
Yes, sir.
Okay. So I will discuss some basics about this industry, that is pulp and paper mill. Everybody knows this is a high pollution load industry also, along with high production of paper. So I would start with the topic, that is utilization of agro residues. Everybody knows agro residue, about agro residues. What are agro residues? So in northern part of this country, we all know that the there are major crops, wheat as well as paddy. So after the harvesting of paddy, the residue left over in the field is rice straw. Similarly, after the harvesting of wheat, here the residue is wheat straw. There is difference between rice straw and rice husk. When you harvest paddy, you get rice in a covered form. The outer cover of that is known as rice husk, whereas the fibrous portion left behind as a plant, that is rice straw. So rice straw and wheat straw, major crops in this part of the country. Suppose Punjab ka case le hum, so lot of nowadays there is a hue and cry about the burning of this residue, that is rice straw. So if I talk about from the environment point of view, this rice straw, what the farmers are doing to clear the fields of their field, so they just burn. But we all know this is a biomass. This is energy. So we must recover this energy. We should not waste this energy. First, we are wasting the energy. Second thing, we are polluting our environment. Because when you burn that residue rice straw, lot of gases like carbon monoxide, carbon dioxide, some methane gases are coming out after burning. So these are the greenhouse gases. So they pollute the environment. Everybody can easily experience the condition. Nowadays, even in Delhi news, you see news are coming that there is so much particulate matter as well as carbon monoxide layer just above the normal population. So that causes so many problems, health issues. So by the utilization of these agro residue materials, we can get rid of this problem. How we can utilize? There is big use. Major use is we can produce paper or pulp. We all know that the paper is made of chemical component of paper product. Paper is the cell. Now, from where we can obtain this cell? We all know that organic material like wood or non-wood like sarcanda, etc., or maybe grass, that contains major portion is cellulose. So, if we can substitute, we all know that from wood, the ideal raw material for paper manufacturing is wood. But it's scarce. This source is scarce in our country. Wood is of, चलो मैं थोड़ा वक्त के साथ बताता हूँ, पहले इधर थोड़ा सा डिस्कस करते हैं with respect to slides. The Indian industry, the pulp and paper industry in India has a tremendous growth potential, which is currently estimated at 7% per annum. In India, almost 800 pulp and paper industries having installed capacity of 12.7 million tons. And in our state, that is Punjab, there are 75 papers. This is the data that I could gather from the literature. Non-wood based paper mills, non-wood means, थोड़ा सा मैं इस स्लाइड पे थोड़ा सा टाइम लेता हूँ पहले बोलना. Non-wood means, non-wood itself indicates non-woody materials. Which are non-woody materials? Maybe sarcanda, grasses. Grasses कौन से? Sabai grass, elephant grass. Your bamboo is non-wood material. If I classify the raw materials for paper manufacturing, for paper, woody material, non-woody materials, agricultural residue. Wood is of two types. One is softwood, another is hardwood. Softwood you can find in the hilly areas. जहाँ पे ठंड है, पे softwood मिलेगी. अपने एरिया में you can easily see the trees which are around us. that comes under the category of non. Similarly, if second category non, जैसे मैंने बताया grasses, sarkanda, bamboo, these are the non-woody raw material. And third one is the agricultural residue on which we are concentrating. Agricultural residue like wheat straw, rice straw, maybe cotton straw, these can be utilized for paper manufacturing. If I see the composition in the subsequent slide, I will show this composition of these raw materials. Now come to this slide, non-wood based paper mills, the paper mills which are utilizing non-woody raw material, contributing over 70% to total country's production. So non-wood based पेपर मिल्स हैं जो वो 70% जो हमारी प्रोडक्शन है वो कंट्रीब्यूट कर रहे हैं फ्रॉम व्हीट स्ट्रॉ, राइस स्ट्रॉ, बायोगैस, सरकंडा एक्सेट्रा. दिस ग्रास is rice. Otherwise, waste and waste paper as such converting waste into wealth and consuming forest resources to an extent to 20 million trees per year. So another good raw material the itself paper, used paper, or we can say recycled paper is another source. See the slide carefully. This gives the per capita consumption of paper of various countries. First table gives the country wise, then emerging countries ka data hai, then developed countries. Now if you see the Asian consumption, that is 45. See the China, 76 kg per capita consumption, whereas India only 13 kg. And in UK and USA, you can see the data that is 135 and 217 kg per capita. Per capita means per kg per an year, per person. So there is the quantity that we are, per capita consumption of our country is very low. But the production, from the production point of view, India ranks 15th among the paper producing countries of the world. The source is, there is a report that you can follow from this reference if someone wants. Now another data from the structure of Indian paper industry. Wood based are 30 mills, agro based 150, and recycled fiber based are 570. So almost 759 का जो data है, this data have taken from a report on opportunities for green chemistry initiatives, which has been submitted to the office of the principal scientific officer to the government of India 2014. So you can see the data of production and then percentage here. Among the top producers of paper, India ranks at 20th position, which is the latest information, with an estimated production of 10.9 million ton per annum. The Indian sector accounts for about 2.6% of the global production, estimated at 390 million ton per annum. So in another words, we can speak, the Indian paper industry ranks 6th among the energy intensive industry, with an energy requirement of about 10 million ton per annum of coal and 10.6 gigawatt hour. जैसे मैंने अभी बताया था, sources of raw material, so woody, non-woody, sarkanda is there, bamboo is there, subai grass is there, kahi grass is there. There are different types of grasses are there. Similarly, under the agriculture residue, wheat straw, rice straw, bagasse, cotton, etc. So if we can utilize these agricultural residues as raw material, then we can solve the problem of environment, as well as we can well conserve the energy that we are wasting by burning these raw. राइस स्ट्रॉ का हमारी तरफ सारे लोग जानते हैं कि हमारी राइस स्ट्रॉ की प्रॉब्लम सबसे बड़ी है. हम राइस स्ट्रॉ की यूटिलाइजेशन के ऊपर बात नहीं कर रहे. बायो रिफाइनरीज की कॉन्सेप्ट आ रही है, एथेनॉल प्रोडक्शन की कॉन्सेप्ट इज देयर फ्रॉम दिस बायोमास. इवन देयर आर रिसर्च सेंटर स्पेसिफिकली, you know, who are those centers who are working in the area of bio refineries in India. One in Mohali is there. So, but the commercial scale has not been achieved till date. भाव कहने का ये है कि राइस स्ट्रॉ का अभी भी यूटिलाइजेशन हम नहीं कर पा रहे. Even in my words, in my knowledge, I would say we could not 1 to 10% भी हम इसका utilization नहीं कर सके after production. Rice straw, wheat straw is effectively utilized with different routes. Wheat straw, यदि आप अपने किसान आपको आइडिया होगा, जो जितनी बफलोज हैं, काउज हैं, उनका जो फूड है वो मेजर है wheat straw. But if you see राइस स्ट्रॉ भी कई जगह किसान हैं जो अपने जो उनका एनिमल है उनको डालते हैं, लेकिन animals don't like the rice straw, but they like wheat straw. What's the reason? I can ask from my participants. Someone can tell what's the reason why wheat straw is utilized as a fodder or feed for the animals, whereas rice straw is not. Rice straw can be utilized. If you see the composition, if you see the structure and composition of rice straw and wheat straw, cellulose content, hemicellulose content, या लिग्निन को ज्यादा डिफरेंस नहीं है, लेकिन why can someone speak why rice straw is not a good feed material for the animal? Any participant? Please speak out. Hello, मेरी आवाज आ रही है? किसी के पास कोई आंसर है तो कोई बात नहीं, कोई रफ आइडिया है वो बता सकता है, otherwise I will tell. But no one is going to speak. Am I right? Hello. Okay.
Yes, sir. Yes.
If someone has some idea, they can speak out.
Yes, sir. It's for higher silica content
Yes.
in rice straw.
Then what will happen if the higher silica content is there?
The cows and buffaloes maybe regard this as poisonous or toxic for them, for their
Actually,
digestion.
yes, it is not digestible. मिट्टी है, कहाँ से digest होगी?
Yes, sir.
So this is the major reason. Now, after it, another use is the wheat straw can be easily utilized as a raw material for paper production. But industry, they are facing problems while utilizing rice straw. Again, the same problem, silica problem is there. So I can propose to young researcher, to young students, this is a good research area, how we can extract that silica from the rice straw, and that silica has commercial value. If you find some research paper on this idea, you can easily get good information. But commercial scale abhi bhi nahi aa raha. So coming to the slide, you can see the some photographs about first photograph you see that is a bunch of wheat straw or rice straw. Another photograph or tree, we all know that recycled paper. These are the sources of raw material. You see this slide. This slide gives the idea of how much the composition of individual component in softwood. I am taking the example of softwood. Cellulose fiber is 42%, plus or minus 2%. Hemicellulose is 27%, whereas lignin is 28%. If you roughly I can see, यदि आप ट्री का या कोई भी ऐसे रॉ मटेरियल का जो नेचुरल ग्रास है सपोज, उसका देखें कंपोजिशन, उसमें 3 मेजर कंपोनेंट्स है. वन इज सेलुलोज, अनदर इज हेमीसेलुलोज, थर्ड वन इज लिग्निन. ओके, तो सेलुलोज, हेमीसेलुलोज, लिग्निन 2 to 5% एक्सट्रैक्टिव्स होते हैं जो रेजन्स होते हैं. तो द रिक्वायर्ड रॉ मटेरियल इज सेलुलोज एंड हेमीसेलुलोज. लिग्निन क्या है? लिग्निन एक कलरिंग मटेरियल है, लॉन्ग चेन पॉलीमर कंपाउंड है, केमिकल कंपाउंड है, which aids the binding of the fibers. यदि लिग्निन नहीं होगा तो ट्री खड़ा नहीं हो सकता, ये प्लांट खड़ा नहीं हो सकता अपनी. तो लिग्निन gives the binding between the fibers. ओके, सो ये तो सॉफ्टवुड की कंपोजिशन है. एग्रो रेजिड्यू के बारे में थोड़ा सा हम पढ़ सकते हैं इस स्लाइड में से, प्लीज पढ़िएगा. यूज ऑफ नॉन, ये इंफॉर्मेशन थोड़ी सी मैं दोबारा वही इंफॉर्मेशन दे रहा हूँ जो मैं बोलना भी था। यूज ऑफ नॉन एग्रो बेस्ड रॉ मटेरियल इज वाइड स्प्रेड इन डेवलपिंग कंट्रीज। लार्जेस्ट नॉन वुड बेस्ड फाइबर प्रोड्यूसर इज चाइना, फॉलोड बाय इंडिया एंड थाईलैंड। So there are 3 categories, वही जो मैंने अभी बताया था, hemp, leaf, flax, jute, ये 1 category है under the non-wood fiber, agricultural residue है। तीसरा wild plants है जो bamboo या grasses कह सकते हैं। So why I am stressing this agro-based raw material to this, because this part of our country we got lots of this raw material, that is agro-based. So we have to think how we industry is utilizing, but industry is facing problems. मैंने पहले बताया कि सिलिका की प्रॉब्लम बहुत बड़ी है। कहाँ प्रॉब्लम होती है? जब इक्विपमेंट्स में ये रॉ मटेरियल यूटिलाइज करते हैं हम, तो देयर आर चांसेस व्हेन वी रिकवर द ब्लैक लिक्विड, मैं बताऊंगा आगे, तो उनकी इवेपोरेटर के ट्यूब्स के अंदर ये जम जाता है सिलिका, तो एक्सट्रीम कंडीशन में चोक हो जाती है। तो दिस इज अनदर रीजन कि वो राइस स्ट्रॉ क्यों नहीं यूटिलाइज कर सकते। फाइबर लेंथ भी थोड़ा कम है, बताएं देखिए। तो फाइबर सोर्स ऑफ दिस टेबल गिव्स द आइडिया अबाउट फाइबर सोर्स ऑफ इंडियन पेपर इंडस्ट्री। यू कैन सी द डेटा, almost 22% is the fiber giving fiber source agrobees. This table gives the data of the approximate fiber length, cellulose content and lignin content. Before this slide, discussion of this slide, I can tell you, if I ask someone what is definition of paper, how we can write paper? It is a sheet. Paper, it is a sheet of cellulose, nothing else. If I ask what is pulp, it is a commercial form of cellulose. We get pulp first from the raw material. We get pulp, then that pulp is easily converted into sheet. So sheet क्या है? एक मेटेड फॉर्म है सेलुलोज फाइबर, सेलुलोज एंड सेलुलोज फाइबर कह सकते हैं। अब थोड़ा सा इस कंपोजिशन के बारे में देखें। जितना फाइबर का लेंथ अच्छा होगा उतना ही पेपर हमारा स्ट्रॉन्ग होगा। तो फाइबर लेंथ क्या है, कौन से मटेरियल की क्या है, देख सकते हैं। यू सी द फर्स्ट कॉलम, सॉरी सेकंड कॉलम, दैट इज फाइबर लेंथ, देन फाइबर, then cellulose percentage, hemicellulose percentage, and you see, if you see the data of rice straw, the fiber length is 0.5 to 1.4, ठीक है, and the cellulose percentage is 28 to 36, hemicellulose 23 to 28, lignin is 12 to 16. Now again थोड़ा सा और बताना चाहूंगा। मैंने बोला है, I have spoken that the cellulose and hemicellulose we need to make the paper. It means we don't need it. But in the raw material, if you see, lignin is the binding force between the fiber. Wood is a fibrous material. It means to extract the cellulose and hemicellulose from the raw material, we have to remove lignin. Why we have to remove lignin? Because it binds the different fibers. But to make a pulp, we need individual fibers. First operation, major operation in pulp and paper industry is pulping. Before pulping, the operations are there, but that depends upon the type of raw material. In pulping, what we do, we take the bundle of fibers, like you take a chip of wood, you take a wood chip, or maybe your rice straw, or maybe your wheat straw, maybe bagasse. Then that is a bundle of fibers. We have to individualize that bundle into the individual fibers. So how that can be done? By pulping. Pulping is the first operation in which we produce pulp from raw material, maybe rice straw, maybe. I will tell you with respect to time. Again, ठीक है, तो pulping first operation है जिसमें हम अब पल्पिंग भी 3 टाइप्स की, केमिकल पल्पिंग, मैकेनिकल पल्पिंग एंड द कॉम्बिनेशन ऑफ बोथ केमिकल एंड मैकेनिकल. Okay, chemical pulping in itself indicates we have to use certain chemicals. In mechanical pulping, we don't use any chemical. We use mechanical force to individualize the fibers, so that bundle of fibers को individual fiber बना देते हैं. ठीक है जी, मैं बताऊंगा उसमें क्या करते हैं आगे बढ़ते हैं. तो आपने आइडिया लेना कहाँ से सेलुलोज है सेलुलोज. इफ आई कंबाइन द सेलुलोज एंड हेमीसेलुलोज, इस कट्ठे को बोला जाता है होलो सेलुलोज. द होलो सेलुलोज कंटेंट इज अबव ऑलमोस्ट 50, 55, 60%. रेस्ट लिग्निन एंड एक्सट्रैक्ट. So our target, if I ask my undergraduates, chemical engineers, or maybe biotechnology engineers, or from the engineering point of view, if I ask how much is the yield of this chemical pulping, maximum 60%, 50%, because my yield product कौन से सेलुलोज एंड हेमीसेलुलोज. लिग्निन आइडियल नहीं आना चाहिए, क्योंकि लिग्निन ही तो मैं रिमूव करता हूँ पल्पिंग में, पर वहां आ जाता है, वो बताएंगे वक्त के साथ कितना आ जाता है. तो द फाइबर प्रॉपर्टीज है क्लियर. यदि किसी को कुछ पूछना चाहते हैं तो पूछ सकते हैं मेरे से. दिस इज द ब्लॉक डायग्रामेटिक रिप्रेजेंटेशन ऑफ द प्रोडक्शन ऑफ पल्प एंड पेपर. बहुत ही सिंपल ये स्लाइड है. देखो वुड है आपके पास, यहाँ पे आप रॉ मटेरियल अपना कोई एग्रीकल्चरल रेजिड्यू दे सकते हैं. सपोज यू हैव राइस स्ट्रॉ. राइस स्ट्रॉ यू नो, पराली जिसको पंजाबी में भी बोला जाता है. कई बार फ्रूट ट्रे हम घर में लेके आते हैं, फ्रूट का टोकरी, उसके नीचे येलो येलो से फाइबर रखे होते हैं, दैट इज योर राइस स्ट्रॉ. कई बार बच्चों की इतनी कॉमन सेंस आजकल कम हो जाती है कि राइस स्ट्रॉ या व्हीट स्ट्रॉ, कभी फिजिकली उनको पता ही नहीं चलता कि राइस स्ट्रॉ क्या है, व्हीट स्ट्रॉ क्या है. ठीक है भाई. जो पशु खाते हैं उसको तूड़ी कहते हैं, उसको हम कहते हैं व्हीट स्ट्रॉ. राइस स्ट्रॉ भी एक फाइबरस पोर्शन है, पराली कहते हैं पंजाबी, नॉर्थ इंडिया की टर्म है. मोस्ट ऑफ द पीपल यू मे नो. तो मैंने बता दिया कि ये पराली होती क्या, लॉन्ग फाइबर्स रहते हैं. ठीक है, दैट इज रेजिड्यू. पैडी का जब प्लांट लगाया जाता है, जब पैडी निकाल ली जाती है ना, आफ्टर हार्वेस्टिंग द पैडी, जो राइस तो ले लिया जाता है, लेकिन जो पीछे का लेफ्ट पोर्शन है दैट इज राइस. सपोज यू वांट टू मेक पेपर फ्रॉम राइस. अब जो फर्स्ट ऑपरेशन है ना पल्पिंग, वो मैं समझाऊंगा कि व्हाट इज पल्पिंग. अब आपके पास राइस स्ट्रॉ है. अब मैं इसकी एग्जांपल सिमिलरली इमिटेट करने की कोशिश कर रहा हूं कि घर में आपने सब्जी बनानी है आलू की. यू हैव पोटैटो and you want to make vegetable of that. Okay, what are the different steps? Everybody knows, I think so. ठीक है जी, मैं तो बहुत अच्छे तरीके से समझा. तो सपोज यू आर गेटिंग पोटैटो फ्रॉम द मार्केट. अब पोटैटो को पहले क्या करते हो, यू वॉश, है ना, ताकि उसके ऊपर मिट्टी वगैरह. आफ्टर वॉशिंग यू रिमूव द आउटर लेयर ऑफ पोटैटो. पील ऑफ कर देते हो आप आउटर लेयर. ठीक है. देन उसको छोटे छोटे पोर्शन में काट लेते हो, चिप्स कह सकते हो. ठीक है. उसके बाद फिर उसको धो लेते हो सब्जी के लिए. नहीं, अदरवाइज यू पुट इन ए प्रेशर कुकर. आपकी किचन में प्रेशर कुकर है. ठीक है जी. वो प्रेशर कुकर आप गैस के ऊपर रखते हो. उसमें आप अपने पोटैटो जो आपने चिप्स फॉर्म में ले लिए थे वो बना डाल देते हो. देन यू पुट रिक्वायर्ड क्वांटिटी ऑफ वाटर एंड देन यू पुट certain masala, namak, mirchi and other masala, and then you close the lid of that digester, cooker. फिर आपको पता है कि ये कुकर की 2-3 सीटी बन जाएंगी एट डिजायर्ड टेम्परेचर. प्रेशर में इतना रेजिडेंस टाइम दूंगा तो मेरी सब्जी बन जाएगी. एम आई राइट? सभी को समझ आ गई मेरी सब्जी बनाई हुई? यस. तो आप बोल सकते हैं बेटे, वक्त के साथ आप पूछ सकते हैं मेरे से. मैं पार्टिसिपेंट्स को कह रहा हूँ यदि सुन रहे हैं. तो अब क्या है, इंडस्ट्री में भी हम वहां पे भी किचन में भी कुकिंग किया, इंडस्ट्री में भी पल्पिंग को कुकिंग से भी जाना जाता है. तो वी कैन, और किचन में भी कुकर यूज करते हैं वर्ड, इंडस्ट्री में भी डाइजेस्टर या कुकर यूज करते हैं ना. सेम प्रेशर वेसल है, सिमिलर आई शुड से, सिमिलर प्रेशर वेसल है, यू पुट, सपोज यू आर टेकिंग वुड एज रॉ मटेरियल। मैं सबका एग्जांपल दे रहा हूं आपको, घबराएं कि सर आपने तो राइस स्ट्रॉ ली या व्हीट स्ट्रॉ ली, ठीक है। सपोज you are getting wood from the forest. There is an outer layer on the log of wood that is known as bark. First what you do, similar to the वही मैं पोटैटो की सब्जी बनाई है, वैसे स्टेप्स मैंने बनाए हुए हैं, आपको ध्यान आ जाएगा, भूलोगे नहीं कभी भी, क्यों आज समझा रहा हूँ, मेरे ध्यान से सुनना चाहोगे। तो आपने लॉग ऑफ वुड जो लिया हुआ दिखाया हुआ फिल्म में, सामने पिक्चर में दिखा रखा है, इसके ऊपर बार्क की लेयर है, वो उसको हम रिमूव कर देते हैं। द इंडस्ट्रियल ऑपरेशन इज नोन एज डीबार्किंग। डीबार्किंग यदि आप गूगल करेंगे या कोई बुक उठा लेंगे तो उसमें फर्स्ट ऑपरेशन वुड बी डीबार्किंग। फिर बार्क रिमूव करने के बाद फिर हम धो लेते हैं, समटाइम्स ड्राई क्लीनिंग करते हैं, समटाइम्स वेट क्लीनिंग करते हैं, डिपेंडिंग ऑन द क्वालिटी ऑफ द कंडीशंस। क्लीनिंग के बाद फिर आपने क्या किया, उन चिप्स को उन पोटैटोज को क्या किया था, काटा था। सिमिलरली उन वुड, लॉग ऑफ वुड को भी छोटे छोटे चिप्स में काट देता है, अबाउट 1 इंच साइज के चिप्स बना लिए जाते हैं। दैट इज नोन एज, ऑपरेशन इज नोन एज चिपिंग। आफ्टर चिपिंग व्हाट वी हैव डन इन विद रिस्पेक्ट टू जो सब्जी बना रहे थे, देन वी पुट इन द कुकर। सिमिलरली है जो पल्पिंग का ये जो डायग्राम आपको दिख रहा है, ये जो डायग्राम आपको दिख रहा है, दिस इज ए कुकर, दिस इज ए पल्पर, दिस इज ए डाइजेस्टर। डाइजेस्टर मीन जिसमें डाइजेस्ट करना है, फूड को डाइजेस्ट करना है। उस आलू की सब्जी को हमने क्या किया था, हाई टेम्परेचर प्रेशर के अंदर डाइजेस्ट किया था। वो आलू जो हार्ड होता है आफ्टर डाइजेशन वो सॉफ्ट हो जाता है। सिमिलरली हियर आल्सो when you put wood chips or maybe your wheat straw in the chip form, or maybe your rice straw in the chip form, or maybe bagasse in the desired size and shape, when you put in this pulper, now उसमें क्या डाला था हमने, फिर नमक डाला था, मिर्ची डाली थी, पानी डाला। Here also you have to add certain chemicals if we are doing chemical pulping. If we are doing mechanical pulping, that mechanism is different, I can tell you if someone will ask. नहीं तो हम पूरा नहीं कर पाएंगे प्रोडक्शन ऑफ पल्प एंड पेपर पूरा, ठीक है, काफी लंबा है। तो इसमें क्या, फिर पानी डाल दिया, पानी में कुछ केमिकल्स डाल दिए। कौन से केमिकल, सिमिलरली केमिकल पल्पिंग की बात कर रहे हैं तो सर्टेन केमिकल्स आर बीइंग यूटिलाइज्ड। व्हिच केमिकल, ये केमिकल पल्पिंग भी 2-3 टाइप्स की है, तो मैं सिर्फ आपको बहुत ही बेसिक सा आइडिया दे रहा हूँ। खैर आप पढ़ते भी होंगे अंडर ग्रेजुएट में। इसमें हम केमिकल पल्पिंग के अंदर सोडा पल्पिंग या क्राफ्ट पल्पिंग कहते हैं। सोडा पल्पिंग या इसको, ये कौन सी पल्प अंडर केमिकल इसके आती है, अंडर अल्केलाइन पल्पिंग, ऐसी एसिडिक पल्पिंग भी होती है। तो केमिकल पल्पिंग जो है उसके 2-3 टाइप्स हैं, तो मैं सिर्फ सेमी केमिकल पल्पिंग भी कहती है। तो हम सिर्फ क्राफ्ट पल्पिंग, यदि आप, इफ यू विल विजिट, देयर इज ए इंडस्ट्री नियर टू जलंधर, अमृत पेपर मिल है, या इधर लुधियाना में पेपर मिल है, अहमदगढ़ में पेपर मिल है, यमुनानगर में बलारपुर इंडस्ट्री का बहुत बड़ा प्लांट है, सहारनपुर में स्टार पेपर मिल है। ये पेपर मिल में जाएंगे आप तो आपको डाइजेस्टर कुकर के नाम से ही इस इक्विपमेंट को जाना जाता है, ठीक है जी। तो उसमें केमिकल्स कौन से डालने हैं, सोडा पल्प। सोडा पल्पिंग में ओनली सोडियम हाइड्रोक्साइड इज यूज्ड एज ए केमिकल। क्राफ्ट पल्पिंग में क्या है, अलॉन्ग विद सोडियम हाइड्रोक्साइड सोडियम सल्फाइड डाला जाता है। ये केमिकल का रोल क्या है, मैं फिर स्ट्रक्चर पे आता हूँ, रॉ मटेरियल के स्ट्रक्चर पे। उसमें क्या था, सेलुलोज था, हेमिसेलुलोज था, लिग्निन था, मेजर 3 कंपोनेंट थे। अब लिग्निन मुझे निकालना है, क्यों निकालना है, इट इज ए बाइंडिंग force between the fiber as well it is a coloring compound. You need white paper. To obtain white paper you have to remove liquid. That's why we do chemical pulping, means with the help of chemicals we remove lignin. जब ये केमिकल है सोडियम हाइड्रोक्साइड उस लिग्निन के ऊपर रिएक्शन करता है, रिएक्टर है ये, उस लिग्निन के ऊपर रिएक्शन करता है, उसको सॉल्विलाइज बाहर निकाल लेता है फाइबर में से, जो बंडल ऑफ फाइबर था। तो क्या होता है, इससे डाइजेशन हो जाती है अंडर टेम्परेचर एंड प्रेशर। रिक्वायर्ड टेम्परेचर 170 डिग्री सेंटीग्रेड, 2-2.5 घंटे के लिए रख दिया जाता है कुकर। मैं ज्यादा डिटेल में नहीं जाऊंगा, नहीं तो कवर नहीं कर पाएंगे, पर यदि कोई पूछेगा तो बता। तो इसमें इस ऑपरेशन में क्या किया जाता है, वो पल्प को जैसे हमने कुकर की सीटियां बजवाई 3, मीन्स डिजायर्ड प्रेशर मेंटेन किया था, डिजायर्ड टेम्परेचर मेंटेन किया था, और कुछ समय के लिए हमारा कुकर को हमने अंडर द हीटिंग रखा था। सिमिलरली इंडस्ट्रियल कुकर को हम स्टीम हीटिंग से करते हैं, क्योंकि इतना बड़ा सपोज 10 टन का है ना, 10 टन का या 5 टन का है या 2 टन का है, आपका वॉल्यूम मीटर क्यूब है या 2 मीटर क्यूब है, उसको डील करते हैं। इट्स वेरी डिफिकल्ट टू हीट बाय सिंगल पॉइंट हीटिंग। दैट इज देयर आर 2 टाइप्स ऑफ डाइजेस्टर, बैच एंड कॉन्टिन्यूस। बैच की मैं बात कर रहा था, तो जैसे फुटबॉल होती है ना, ऐसे होते हैं बैच के, स्फेरिकल शेप। तो उसमें हम स्टीम की इंजेक्टिंग के थ्रू स्टीम दी जाती है, ओपन स्टीम भी दी जाती है। केमिकल इंजीनियर या बायोटेक्नोलॉजी इमीडिएट मेरे वर्ड्स को समझ रहा होता है कि मैं क्या बोल। तो इस डाइजेस्टर में क्या होता है, वो पल्प फिर बन जाता है, सॉफ्ट हो जाता है जो आम है। तो हमने जैसे अभी मैंने बताया था कि कैसे हमने सब्जी बनाई, उस सब्जी के बाद फिर हम क्या करते हैं, कुकर का ढक्कन खोलते हैं, कुकर का कवर खोलते हैं, वी ओपन द बाय रिमूविंग द प्रेशर। तो सीटी हम खोल देते हैं, उससे प्रेशर रिलीज हो जाता है, एटमॉस्फेयर प्रेशर पे आके वो आपका कुकर खुल जाता है। सिमिलरली यहाँ पे भी ब्लो डाउन इज ए नेक्स्ट टेक्निकल वर्ड which is being utilized, which is a word. Blow down उस डाइजेस्टर को एकदम एटमॉस्फेयर प्रेशर पे उस मटेरियल को लेके आ जाता है। उससे क्या होता है, जो बंडल ऑफ फाइबर अंदर पोले पोले हो जाते हैं, तो इंडिविजुअल फाइबर में वो बदल जाते हैं। वहां स्टीम प्रोड्यूस होती है जो रिकवर कर ली जाती है। हीट रिकवरी जिसको हम कहते हैं, केमिकल नहीं, हीट रिकवरी। वी हैव टू रिकवर दैट हीट, क्योंकि नहीं तो वेस्ट चली जाएगी। तो अब जो पल्प बना, जो सॉफ्ट सा मास बन जाता है, शायद इसमें दिखाया हो मेरे पास नहीं, यहाँ यस, इस फिगर में आप देखेंगे ना, थर्ड पिक्चर देखिए, दिस इज दी वॉश्ड, सॉरी ये देखिए डर्टी पल्प। इस टाइप का जब आप पल्पिंग या सोडा पल्पिंग कर रहे हैं, द रॉ मटेरियल इज योर हीट स्ट्रॉ, then this type colored material you will get. Okay. Similarly, देखो फिगर बता रही है केमिकल पल्पिंग में हमने NaOH डाला, सोडियम सल्फाइड डाला. This is another picture of digester. And this is black liquor is separated from pulp in washing. मैं वहीं जाता हूँ, वहीं जा रहा हूँ. ठीक है. यहाँ भी देखो, यहीं जाते हैं. अब वो जो सॉफ्ट मास सा बन गया ना, उसके अंदर जो हमने केमिकल डाले थे पानी के साथ, वो जो लिग्निन था ना, वो सॉल्वेलाइज हो गया, वो घुल मिल गया उस पानी के अंदर। केमिकल जो उसको ग्रीन व्हाइट लिक्विड बोला जाता है। व्हाइट लिक्विड जो सोडियम सल्फाइड और सोडियम हाइड्रोक्साइड पानी में जब घोल दिया जाता है ना, सोडियम हाइड्रोक्साइड और सोडियम सल्फाइड को, तो उसको पानी में घोलने के बाद उसको व्हाइट लिक्विड बोलते हैं। कलर भी व्हाइट, मतलब कलर ऐसे वो व्हाइट लिक्विड था, जब लिग्निन उसके साथ मिल गया तो उसका रंग काला। उसको टेक्निकल वर्ड जो बोला जाता है, दैट इज ब्लैक लिक्विड। ग्रीन व्हाइट लिक्विड इज कन्वर्टेड टू ब्लैक लिक्विड। उसमें मेजर पोर्शन आपका लिग्निन। लेकिन यदि आपकी कंडीशन, प्रोसेस कंडीशन, ये एक इंजीनियर देख सकता है, मेरे से पूछ सकता है कि यदि आपका प्रेशर, टेम्परेचर, रेजिस्टेंस टाइम, केमिकल ज्यादा आपने लगा दिए वहां, तो वो आपका प्रॉपर रिएक्शन नहीं होगा, सही नहीं होगा, तो आपका जो डिजायर्ड मटेरियल है वो भी टूट जाएगा। सेलुलोज और हैंडी सेलुलोज भी उस गंदे पानी में, उस ब्लैक लिक्विड में सॉल्व होते तो हैं, लेकिन किस हद तक हमने लॉसेस देखने हैं हमारे डिजायर्ड मटेरियल के, दैट डिपेंड्स ऑन द प्रोसेस कंडीशन. So technically process condition, that's why there is a need to optimize the process conditions. Do you agree with me, everybody? If you are not agreeing with me, you please ask. Nobody is asking the question. I don't know whether you are getting my words or just कुछ समझ नहीं आ. ठीक है भाई, चलो मैं another diagram दिखाता हूँ. This is a diagram of the process. Same process को another diagram में दिखा रखा है. I have taken from that same report which I was mentioning earlier also. So इसमें भी देखेंगे आप, you take raw material, okay, then suppose you, in this example they have written one waste biomass, dust, pith, bark. If you are taking wood, pith, if you are taking बेगास। बेगास क्या होती है? जब गन्ना, हम गन्ने का तो सबको पता है, शुगर के, जब गन्ने से जूस निकाल दिया जाता है, जो लेफ्ट ओवर पोर्शन है उसको बेगास कहते हैं। अब बेगास में एक छोटा सा मेजर पोर्शन, उसके अंदर वाइट वाइट सा जो फ्लफी सा पोर्शन है उसको कहते हैं पिथ। दैट इज नॉट फाइब्रस पोर्शन। पिथ इज नॉट ए फाइब्रस पोर्शन। पिथ को हमें फाइबर चाहिए क्योंकि सेलुलोज है। पेपर इज ए फाइब्रस मटीरियल। पेपर इज ए फाइब्रस मटीरियल, तो हमें तो फाइबर चाहिए। पिथ इज नॉट फाइब्रस, सो दैट्स वाई उस सॉफ्ट से पोर्शन को ना निकाला जाता है। उस ऑपरेशन को बोला जाता है डीप पिथिंग, जो यहाँ इसके अंदर किया जाता है, इस स्टेप के अंदर। आफ्टर गेटिंग द डिजायर्ड फॉर्म ऑफ रॉ मटेरियल, देन यू पुट दैट रॉ मटेरियल इन ए डाइजेस्टर। पल्पिंग जिसको कहते हैं, पल्पिंग एंड वॉशिंग यहाँ इकट्ठा दिखा है, पर आप पहले पल्पिंग के ऊपर कॉन्सेंट्रेट, जो मैंने अभी समझाया था। हमने आलू की सब्जी बनाई थी। सिमिलरली यू टेक योर रॉ मटेरियल एंड प्रिपेयर पल्प। Which type of chemicals are utilized in this? Here is mentioned sodium hydroxide, steam, sodium sulfide and water. तो यहाँ से निकला क्या? ब्लैक लिक्विड निकलेगा आफ्टर वॉशिंग। अब फिर क्या करते हैं भाई, आपके पास आफ्टर पल्पिंग आपको क्या मिला? एक तो पल्प मिला, अलॉन्ग विद काफी वो गंदा पानी मिला, ब्लैक लिक्विड मिला। ठीक है, अब नेचुरल द डिजायर्ड प्रोडक्ट इज पल्प. वी हैव टू सेपरेट दैट पल्प फ्रॉम दैट मास स्लरी जो थी पल्प की एंड काले पानी की. हाउ यू कैन गेट दैट पल्प? बाय वॉशिंग. वॉशिंग की जाती है ताकि जो काला पानी था, जो ब्लैक लीक करता है, दैट शुड बी सेपरेटेड आउट. दैट शुड बी separated. How can be done? By utilizing washing operation. Washing जैसे घर में पता है कैसे हम सब्जी को धोते हैं, जाली के बीच में रख लेते हैं. इन द इंडस्ट्री आपके वॉशर यूज होते हैं, जो आपने पढ़ते हैं, आप अंडर ग्रेजुएट में पढ़े होंगे, रोटरी वॉशर. रोटरी वॉशर यहाँ यूज किए जा, अंदर वैक्यूम भी लगा दिया जाता है. सो दैट वॉशर की कॉन्सेप्ट तो मैं नहीं बताने जा रहा हूँ, लेकिन आपको पता है कि सीरीज ऑफ वॉशर्स इस पल्प को निकालने के लिए यूज किया जाता है. ऊपर से पानी स्प्रे किया जाता है, तो जो काला पानी है वो नीचे आ जाता है, जिसको हम ब्लैक लिक्विड कहते हैं. हियर इट इज मेंशन वीक ब्लैक लिक्विड. टोटल सॉलिड 12 से 18% के सॉलिड्स के यहाँ ब्लैक लिक्विड आपको मिल जाता है. ये नहीं चीज मैं समझाऊंगा आपको, क्योंकि ये अनदर एक और पूरा बुक एक 3-4 सब्जेक्ट्स बन जाते हैं इसके ऊपर, तो मैं यहाँ चलूंगा. अब यू गेट पल्प, दैट इज नोन एज अनब्लीच्ड पल्प. व्हाई इट इज कॉल्ड अनब्लीच्ड पल्प? बिकॉज देयर इज ए कलर ड्यू टू रेजिडुअल लिग्निन. हमने देखो पल्पिंग में क्या किया था, हमने सेलुलोज और हेमी सेलुलोज को निकाला, लेकिन साथ में कुछ परसेंटेज में 2%, 4-5% आपका लिग्निन भी आ गया. तो यदि मैं नेक्स्ट फोटो दिखाऊं, यहाँ पे ऐसा वॉश्ड पल्प मिलता है. देखो इसमें कलर है, तो इस कलर को भी हमें चाहिए ऐसा पल्प, ये जो मैं एरो जिसके ऊपर घुमा रहा हूं. ठीक है, ऐसा पल्प चाहिए हमें. पल्प क्या है? जैसे आपके पास व्हाइट पेपर है, उसको कई बार छोटे होते ना, हम लोग मुंह में डाल के खा भी लेते थे, हमें मजा आता. तो जो मुंह में फ्लफी सा पोर्शन बन जाता है ना जब हम चबाते हैं कागज को, तो दैट इज पल्प. तो हमें तो ये पल्प चाहिए भाई. मैं समझाने की कोशिश कर रहा हूँ बेटी, बहुत ही बेसिक्स बताने की कोशिश कर रहा हूँ. ऐसा पल्प चाहिए, ऐसा पल्प, लेकिन मिला ऐसा पल्प, ये अनब्लीच्ड पल्प है. तो अब हमें ये जो कलर है इस पल्प है, इसको भी खत्म करना है. कहने का भाव, नीचे भी शायद कुछ मैंने दिखाई है पिक्चर. चिप्स है, पल्प आफ्टर कुकिंग, वॉश्ड पल्प है, ब्लीच्ड पल्प है. ये देखो ब्लीचिंग, तो इट मीन यू हैव टू डू ब्लीचिंग. ब्लीचिंग है जो अभी मैं एक स्टेटमेंट देने जा रहा हूँ. एवरीबडी शुड नो, एवरीबडी शुड ट्राई टू अंडरस्टैंड. ब्लीचिंग इज ए मल्टी स्टेप प्रोसीजर. आई हैव स्पोकन, ब्लीचिंग इज ए मल्टी स्टेप प्रोसीजर. कहने का भाव, ब्लीचिंग इज नॉट ए सिंगल स्टेप प्रोसीजर. यहाँ से ये तो समझ आ गई बात. सो मल्टी स्टेप प्रोसीजर मीन pulp have to be treated under this section multiple times. So bleaching is a multi-step procedure. अब bleaching में कैसे क्या किया जाता है, रंग को काटना, ब्लीच करके, ठीक है। पल्प का हमने वो जो रेजिडुअल कलर है उसके अंदर लिग्निन है वो निकालना है, उसको ऑक्सीडाइज कर देते हैं। ऑक्सीडाइजिंग एजेंट्स यूज होते हैं, वैसे रिड्यूसिंग एजेंट भी यूज होते हैं, लेकिन मोस्टली इंडस्ट्रीज आर यूटिलाइजिंग ऑक्सीडेंट्स। अब आप सब जानते हैं विच केमिकल्स आर ऑक्सीडेंट, बताएं कोई मुझे बच्चा, कोई ऑक्सीडेंट का नाम बता दें केमिकल का। क्लोरीन, क्लोरीन इटसेल्फ, एलिमेंटल क्लोरीन गुड ऑक्सीडेंट, क्लोरीन डाइऑक्साइड, हाइड्रोजन परऑक्साइड, ओजोन, ठीक है जी, हाइपोक्लोराइड, कैल्शियम हाइपोक्लोराइड, sodium hypochlorite. These are the chemicals which acts as oxidant which remove the residual color. अब पल्पिंग ब्लीचिंग का ना दो ऑब्जेक्टिव्स हैं। वन इज के वो रेजिडुअल कलर खत्म किया जाए, दूसरा कि हमारे ब्राइटनेस भी आ जाएगा। तो दैट्स व्हाई इट इज ए मल्टी स्टेप प्रोसीजर। तो क्लोरीन पहले यूज होती थी, आजकल बैन हो गई है, लेकिन आप सबको पता है इंडिया में क्या नहीं होता। क्लोरीन क्या है एलिमेंट, व्हेन यू ट्रीट दैट पल्प विद द अनब्लीच्ड पल्प विद क्लोरीन, आपका ऑक्सीडेशन होता है, क्योंकि ऑक्सीडाइजिंग एजेंट है जो क्लोरीन। यू आर ट्रीटिंग सेलुलोज और हेमीसेलुलोज विद दिस क्लोरीन, तो आपके ऐसे क्लोरीन, क्योंकि लिग्निन रेजिडुअल लिग्निन है वहां पे, CH कंपाउंड्स के साथ जब क्लोरीन रिएक्ट करती है ना तो क्लोरोलिग्निन्स प्रोड्यूस हो जाते हैं। क्लोरोलिग्निन्स, यदि मैं केमिकल कंपाउंड्स की बात करूं, किस टाइप के कंपाउंड बनते हैं ड्यूरिंग द ब्लीचिंग, क्लोरीन ब्लीचिंग, ऐसे केमिकल जनरेट होते हैं विच आर वेरी टॉक्सिक, विच आर नॉट इजिली बायोडिग्रेडेबल। कौन से नाम बताऊंगा अभी? क्लोरो, क्लोरो ऑर्गेनिक्स, AOX, डायोक्सिन्स, फ्यूरेन्स, क्लोरोफिनोल्स, क्लोरोसिलिनल्डिहाइड्स, कैटिकोल, chlorocaticols. These types of hundreds compounds are being generated during the chlorine phase. That's why these compounds, मैंने फिर वही स्टेटमेंट दे रहा हूँ, I am again giving this statement, the compounds are non-biodegradable. अब देखो ना, ये मैंने स्टेटमेंट क्यों दी भाई? ब्लीच आपने कर लिया क्लोरीन के साथ, आपका डिजायर्ड प्रोडक्ट है पल्प, जो आपने ब्लीच कर लिया, लेकिन अनडिजायर्ड जो उसमें से पानी था, जो पानी अब गंदा हो गया सॉरी, ड्यूरिंग द रिएक्शन वो गंदा हो गया, उसको तो अलग करना है ना, तभी इंटरमीडिएट वॉशिंग करते रहते हैं, इस स्टेज के बाद वॉशिंग करनी पड़ती है। अब यूट्यूब वीडियो देखें, अब थोड़ा लिटरेचर पढ़ें, यदि और अंदर जाता है। आज का लेक्चर तो सिर्फ आपका इंटरेस्ट जगाने के लिए, हमारा केमिकल इंडस्ट्री कितना बड़ा है, एक इंडस्ट्री की बात कर रहा हूँ। आई कैन टॉक अबाउट अदर इंडस्ट्री, मैं पेट्रोलियम की भी बात ऐसे कर सकता हूँ, मैं ऑयल एंड फैट्स की भी बात ऐसे कर सकता हूँ। क्यों कर रहा हूँ? बिकॉज आई हैव इंडस्ट्रियल एक्सपीरियंस, आई हैव वर्कड इन दीज इंडस्ट्री। तो ये जो ब्लीचिंग है ना, जो ब्लीचिंग में से जब हम वॉशिंग करके गंदा पानी निकालते हैं, उस पानी में वो सारे कंपाउंड आ जाते हैं जो कि एफुलेंट ट्रीटमेंट प्लांट में जाते हैं। वेस्ट वाटर ट्रीटमेंट प्लांट में these compounds they enter into the wastewater treatment plants, and you can easily imagine how difficult that type of pollution load which is being generated in this section to handle. Very difficult to treat these chlorinated compounds. Please, you try to understand my words. ठीक है, मैं उस पे नहीं जाऊंगा वेस्ट ट्रीटमेंट में, कभी दोबारा मौका मिलेगा तो यहीं से स्टार्ट करके वेस्ट ट्रीटमेंट को एक्सप्लेन करूंगा, कभी सर मौका नहीं। तो जो भाई ये ब्लीचिंग में क्लोरीन डाइऑक्साइड भी यूज करे, फिर कॉन्सेप्ट आया पूरे। अब दीज आर द रिसर्च एरियाज। अभी जो यू आर बायोटेक्नोलॉजी स्टूडेंट्स, बायोटेक्नोलॉजी के स्टूडेंट, यहाँ पे एक स्टेप लिया जाता है, आजकल कॉन्सेप्ट चल रहा है बायो ब्लीचिंग। यू कैन एक्सप्लोर सर्टन बायो एजेंट्स, सम microorganisms, they can do this bleaching. Some commercial technologies are, some enzyme bleaching is there, but research can be easily taken, some project can be easily taken in the area of bio bleaching. यदि बायो ब्लीचिंग करोगे तो क्या होगा, ये हमारे जितने हमने क्लोरीनेटेड कंपाउंड्स की बात करी, जो टॉक्सिक कंपाउंड्स की बात करी, इनका कम हो, ये वेस्ट वाटर ट्रीटमेंट प्लांट है, then there would be so much contribution from the scientist side, from the individual side के मैंने ये टेक्नोलॉजी वर्ल्ड इज डूइंग, काफी वर्क चल रहा है, लेकिन आप भी ऐसा काम ले सकते हैं। मैं यंग स्टूडेंट्स को बात करता हूँ। तो फिर क्या बात आई भाई, एलिमेंटल क्लोरीन को आप रिप्लेस कर दो, एटलीस्ट मॉलिक्यूलर क्लोरीन को यूज कर लो या हाइड्रोजन पेरोक्साइड यूज कर लो, ठीक है। क्यों? इफ यू आर, भाई क्लोरीन सस्ती है, इजीली अवेलेबल है, हमें कॉस्ट तो अल्टीमेटली कोई भी, जब आप इंजीनियरिंग प्रोडक्ट बना रहे हैं, प्रपोज कर रहे हैं, तो अल्टीमेट कॉस्ट पे आगे बात खड़ी हो जाती है। आपने बड़ी अच्छी रिसर्च की, लेकिन वो कॉस्ट वाइज कॉम्पिटिटिव नहीं है, तो वो नहीं प्रोडक्शन कमर्शियल स्केल पे जा सकती। तो क्लोरीन डाइऑक्साइड की कॉन्सेप्ट आई, तो क्लोरीन डाइऑक्साइड भी काफी हद तक यूज हो रही है। क्लोरीन तो बैन होगी, लेकिन फिर भी हो सकता है यूज हो रहा है, ठीक है। तो क्लोरीन डाइऑक्साइड भी यूज हुई, कंपाउंड तो सिमिलर बनते हैं कहता ड्यूरिंग ब्लीचिंग, लेकिन द क्वांटिटी ऑफ दोज कंपाउंड जनरेटेड कंपाउंड्स की क्वांटिटी कम हो सकती है, दैट हैज बीन नोन इफ वी यूज, दैट हैज नोन इफ यू यूज क्लोरीन डाइऑक्साइड। तभी इफ यू टेक ए रजिस्टर, क्लासमेट का आप रजिस्टर लेते हो मार्केट से, तो लास्ट पेज पे ना आप देखें, नीचे लिखा होता है दिस प्रोडक्ट इज क्लोरीन फ्री, एलिमेंटल क्लोरीन। तो वो कहने का भाव है, वो इंडस्ट्री है जो वो क्लोरीन ब्लीचिंग नहीं करती है, वो क्लोरीन डाइऑक्साइड हो सकता है यूज करती हो, या अदर ऑक्सीडाइजिंग एजेंट्स यूज करती हो, हाइड्रोजन पेरोक्साइड करती हो, ओजोन। तो ऐसा ही ना, दिस इज अ सीरियस, यस सर, यस सर, एनी क्वेश्चन? ओके, तो मैंने जैसे पहले बोला था कि क्लोरीन इज ए, ब्लीचिंग इज ए मल्टी स्टेप प्रोसीजर। तो पहले क्लोरीन करते हैं, क्लोरीन डाइऑक्साइड, क्लोरीन यूज होती है, फिर क्लोरीन डाइऑक्साइड यूज होती है, फिर हाइपोक्लोराइड यूज होता है। देयर आर सीक्वेंसेस, इसके ऊपर भी बहुत रिसर्च है, एंड द कमर्शियल सीक्वेंसेस आते हैं, ठीक है, कि मैंने पहले क्लोरीन डाइऑक्साइड लगानी है, उसकी प्रोसेस कंडीशंस क्या है, फिर सपोज हाइपोक्लोराइड लगाना है, उसकी प्रोसेस कंडीशंस क्या है, फिर ओजोन ब्लीचिंग करनी है, या मुझे बायो ब्लीचिंग करनी है। देयर आर कमर्शियल एस्पेक्ट्स आर देयर, वेल एस्टैब्लिश्ड टेक्नोलॉजीज आर। सो इन माय व्यू सभी को समझ आ गया होगा। आप देखें यहाँ कुछ लिखा हुआ है, क्लोरीन, क्लोरीन डाइऑक्साइड, हाइड्रोजन पेरोक्साइड एंड सोडियम हाइड्रोक्साइड। सोडियम हाइड्रोक्साइड से तो हम वॉशिंग करते हैं, ठीक है जी। तो यहाँ से एफुलेंट लोड भी लिख रखा है ब्लीचिंग का, जस्ट से एफुलेंट लोड 30 मीटर क्यूब पर टन, यही होगा। कलर, सीओडी, तीन पैरामीटर्स ऑफ दैट। अब आपके आफ्टर ब्लीचिंग यू गॉट दिस टाइप ऑफ पल्प, इस टाइप। ये सिर्फ मैंने ब्लीच प्लांट का एग्जांपल दिखाया हुआ, एग्जांपल ऑफ ब्लीच प्लांट वॉशिंग लेआउट। ये देखो, ये ब्लीचिंग टावर है, ये रिएक्टर्स है, यहाँ वॉशर की ये रोटरी फिल्टर होते हैं, उनका डायग्राम मल्टी स्टेप है। यहाँ से भी आप देखोगे मल्टी स्टेप प्रोसीजर, एक टावर, दूसरा टावर, तीसरा टावर, वॉशर्स भी है, फिल्ट्रेट टैंक्स, ठीक है। तो मुझे लगता है ये पिक्चर पूरी क्लियर होगी। ये और भी एक पिक्चर जैसे मिल जाती है नेट पे, मैंने दिखाया था कि टिम्बर मैकेनिकल पल्पिंग की बात नहीं कर रहा थी, चिपिंग, देन केमिकल पल्पिंग, उसके बाद में है कि उसका नेक्स्ट ऑपरेशन इज ब्लीचिंग, जो ब्लीचिंग हमने अभी यहाँ डील कर। अब आफ्टर ब्लीचिंग ना, यू गॉट ब्लीच्ड पल्प, यू गॉट पल्प हैविंग डिजायर्ड ब्राइटनेस, ठीक है जी। अब उसके बाद आपने क्या करना है, उस पल्प को नेक्स्ट सेक्शन में लेके जाना है, दैट इज नोन एज स्टॉक प्रिपरेशन सेक्शन। स्टॉक मीन मास, स्टॉक प्रिपरेशन। वहां पे ना आपको अपना जो पल्प बन गया, ब्लीच्ड पल्प जो आपका है, उसके अंदर डिजायर्ड प्रॉपर्टीज एनहांस करनी। फॉर एग्जांपल, आपकी सिगरेट पेपर, व्हाट शुड बी द बेसिक प्रॉपर्टी ऑफ सिगरेट पेपर? समवन कैन टेल, आई वुड बी वेरी हैप्पी, कोई बताए। अच्छा, आपने बॉन्ड पेपर बनाना है, आपने लैमिनेटेड पेपर बनाना है, आपने मैपलिथो बनना है, डिफरेंट टाइप्स ऑफ पेपर, 100 ग्रेड्स ऑफ पेपर आर अवेलेबल इन मार्केट। तो कुछ प्रॉपर्टीज इस सेक्शन के अंदर उसमें जनरेट कर दी जाती है। यहाँ उसने दिखा दिया, ये देखो फिलर्स, यस you need to add certain fillers. Then in this section that those fillers can be added. Retention aids, sizing aids. इसका मेजर ऑपरेशन दो ही है, एक तो मैकेनिकल ट्रीटमेंट दी जाती है, एक इस सेक्शन में केमिकल ट्रीटमेंट। मैकेनिकल ट्रीटमेंट को साइजिंग है, फाइबर्स को सीधा करना, उल्टे सीधे फाइबर टेढ़े मेढ़े ना हो, सीधे हो, जितने सीधे होंगे उतनी स्ट्रेंथ बढ़ जाएगी पेपर की। मैं ज्यादा ना बोल, नहीं तो फिर आप बोर हो। तो यहाँ भाई वो सारी प्रॉपर्टी, कोई कलर पेपर चाहिए आपको, यू कैन ऐड सर्टेन डाइज। आपको रेड कलर का पेपर चाहिए, ब्लू कलर का पेपर चाहिए, दोज डाइज कैन बी एडेड इन दिस स्टेप, स्टॉक प्रिपरेशन स्टेप। अब इस स्टेप में ना, इस स्टेप के बाद द स्टॉक इज रेडी टू प्रोड्यूस शीट, द पल्प इज रेडी टू प्रोड्यूस शीट। आगे का मैं जस्ट आगे दिखाऊंगा आपको कैसे बनाया जाता है। You just note down this paper machine section. यहाँ बैकवर्ड और फिनिश्ड पेपर, यहाँ से पेपर बन जाता है। ये चीजें नहीं मैंने बात की केमिकल रिकवरी। केमिकल रिकवरी इज अनदर 3 घंटे लगेगा, पर यहाँ मैं बताऊंगा पेपर मशीन कैसे काम करती है। तो अब मैं आगे चल रहा हूँ। तो ये पल्प है, देखिए फाइबर्स इन पल्प, फाइबर्स का देखो माइक्रोस्कोपिक पिक्चर दिखा रखा है। फाइबर लेंथ, फाइबर डायमीटर, can easily you can have some idea from the magnifying ये सेम इमेज। अब ये मैंने कुछ एनिमेटेड मुझे मिल गए थे, तो मैंने दिखा दिया कि सिंपली ये देखो दिखाया कि रिफाइनिंग क्या होती है, मैकेनिकल ट्रीटमेंट, ये भी रिफाइन। अब इसमें देखो मैंने पेपर मेकिंग, पेपर मेकिंग को समझने के लिए मैं इजीली बताऊं, आपके पास बहुत ही डाइल्यूटेड सा लिक्विड है जिसमें बहुत फाइबर्स हैं, डाइल्यूटेड फॉर्म में। यदि आपके घर में जाली नहीं होती, जो आटा जिससे हम छानते हैं सी, उसमें से उसको पास करें तो सॉलिड मटेरियल जो फाइबर है उसके ऊपर बन जाएंगे, रह जाएंगे, पानी नीचे निकल जाएंगे, ठीक है। वहां ऊपर एक लेयर सी बन जाएगी और एक वो उसको हम सुखा लें तो एक शीट बन जाएगी। इसी फिनोमेना को यहाँ पे शीट फॉर्मेशन के लिए एक ये डब्बा बना दिया, बॉक्स बना दिया, इसको वैसे बॉक्स कहते हैं। तो चलो आगे आगे शायद इसके अंदर ना बहुत ही डाइल्यूटेड उस पल्प को रख दिया जाता है और यहाँ से एक ओपनिंग बना दी जाती है। यहाँ तो ये तो सिर्फ दिखाने के लिए है कि टैप लगा दी उसने। ये एक जाली है, दिस इज सी बेल्ट कहते हैं, ये रन करती है बिटवीन द रोटर्स। इसको हेड बॉक्स कहते हैं, दिस इज द हेड बॉक्स। इसके अंदर हम होमोजेनियस कंडीशन रखते हैं जिस तरह लगाए। तो ये ना एक आप देखो रोल्स चल रहे हैं, ये एक वायर मेश चल रही है, वायर ये चल रही है बिटवीन दीज टू। ये चीज वो है, ये वाली चीज, ये वायर मेश ये चल रही है। अब देखो यहाँ स्लूज से ना बहुत ही बारीक सी ओपनिंग है जिसमें से जो आपका पल्प है इन वेरी डिल्यूटेड फॉर्म, लेस देन 1% और 1% स्लरी कहते हैं इसको, मेंटेन कहते हैं। तो बहुत ही पतला सा वो लिक्विड है जो बहुत ही हाईली डिल्यूटेड है, वो इसके ऊपर छनता जाता है। तो होता क्या है, पानी नीचे निकल जाएगा, शीट ऊपर बनेगी, शीट पर। हाँ जी,
Yes, sir, your voice is breaking.
ओके, अभी नहीं आ रही?
हाँ, थोड़ा सा बीच में टूट टूट के आ रही है।
ओह, आई एम सॉरी मैम।
थोड़ा माइक को थोड़ा दूर रख के अगर आप माइक यूज कर रहे हो सर।
नहीं, मैं तो ये हाँ जी माइक्रोफोन ही यूज कर रहा हूँ।
हाँ, थोड़ा सा दूर उसको करके अगर।
अभी आ रहा है कुछ? ठीक है,
हाँ जी, अब ठीक आ रहा है सर।
अच्छा, ये इस मशीन को फूड ड्राइंग मशीन कहते हैं। ये देखो ना, आप फिजिकली जस्ट इमेजिन करिए, आपने कभी इंडस्ट्री में नहीं गए, जो गए हैं तो वो कैन इजीली अंडरस्टैंड दिस द वायर mesh which is running between two rods at high speed. When the material from this opening will fall onto this mesh, what will happen? The water will be separated out or drained out through the hole through the sleeves of the wire mesh, and the sheet will be formed. It is a continuous operation from this point to this point. जहाँ तक वो पैकिंग नहीं होता, ये नीचे दिखाया गया. This is a continuous operation. This is an entire continuous operation. So once you start from here, you will come end with this point. First sheet formation. This is known as wet end. This is a wet press section. Then dry section. Then blending section. Here there is a blending role. Okay, different roles are there. I will not get into these individual roles. मेरे तो चक्कर पड़ जाएगा. यहाँ वैक्यूम फॉइल्स भी लगाते हैं हम. ठीक है, ताकि जो पानी है वो यहाँ तो अपने ग्रेविटी से पानी निकल जाएगा, जो रह गया फिर वो सक कर लेते हैं. सक्शन बॉक्सेस लगे रहते हैं और वैक्यूम बॉक्सेस लगे रहते हैं, जिसमें वैक्यूम अप्लाई करते हैं. ये कॉन्टिन्यूस ऑपरेशन है. माइंड इट. अब यहाँ इस पॉइंट पे आती ना शीट बन जाती है. यहाँ तो सॉलिड मास था पानी, यहाँ तक आते वो शीट बन जाती है. जब शीट बन गया, अब मुझे पता है कि मैंने उस शीट को थोड़ा दबाऊंगा तो पानी निकल जाएगा उसमें से. तो आगे आपका प्रेसिंग सेक्शन रहता है. प्रेसिंग जो सेक्शन है उसमें क्या है, दो के बीच में से शीट को, दो रोल्स के बीच में से शीट को निकाला है ताकि थोड़ा सा प्रेशर अप्लाई करते हैं. देखते टेक्निकल पॉइंट है. ठीक है, लेकिन ये फेल्ट है. फेल्ट हेल्प करती है कि पेपर नेक्स्ट मूव कर दे, नेक्स्ट रोल पे कर दे. ये देखो, तभी यहाँ पे वेट प्रेस सेक्शन है. अब प्रेसिंग कर लिया, आपकी शीट का जितना भी मॉइस्चर यहाँ हो सकता था कर लिया, लेकिन उसके अंदर अभी भी पानी की क्वांटिटी है. तो फिर क्या करते हैं हम, ड्राई पेपर, फिर ड्रायर सेक्शन में देखते. इसलिए ड्रायर सेक्शन, दिस इज ए ड्रायर सेक्शन. लाइव पिक्चर देखिए. ड्रायर सेक्शन ऑफ एन ओल्ड कोड ड्राइंगर स्टाइल पेपर. कोड ड्राइंगर ब्रदर थे जिन्होंने ये मशीन निकाली थी, उनके नाम पे ये इस मशीन का नाम है. इसमें क्या है, सीरीज ऑफ रोल्स लगाते हैं. आप देख सकते हो कितने रोल्स. ये स्टीम हीटर इंटरनल, और इनके ऊपर फेल्ट के साथ पेपर चलता है. फेल्ट है ये, और पेपर शीट भी चलता है. ब्लू वाली पेपर शीट है, आप देख सकते हैं. और यहाँ तक मैक्सिमम ड्राई हो गया. ड्राई के बाद जैसे हम कपड़े को प्रेस करते हैं, ऐसे ही हाईली सरफेस फिनिश्ड रोल्स रहते हैं. ठीक है जी, वो उनके थ्रू में पास कर दिया जाता है पेपर. तो प्रेसिंग तो और उनकी सरफेस फिनिश आए. तो दिस इज द ड्राइड प्रोडक्ट इन दिस. मैंने शायद कुछ फोटो और भी ये वैसे ही मिला है एनिमेटर. तो ये देखो, कॉन्टिन्यू शीट आ रही है और रील पे चढ़ रहा है. दिस इज अ सेक्शन ऑफ शीट ड्राइंग, जो अभी ड्राइंग का वर्क. पेपर इज मूविंग विद द हेल्प ऑफ फेल्ट्स ऑन टू द रोल. बोथ साइड पेपर की हमने एक्सपोज करनी है हीटेड सरफेस के ऊपर, इसलिए ऐसे सेक्शन बनाएगा, ऐसे अरेंजमेंट बनाए. बोथ साइड्स ऑफ द पेपर यू सी हैज बीन एक्सपोज्ड against the heated roll. The surface of these rolls is very highly surface finished रहते हैं ये. नहीं तो यदि थोड़ा सा भी कोई this section आप देखो, this section is totally covered, क्योंकि मामूली सा भी कोई डर्ट, कोई आपका कोई सैंड या कोई मिट्टी का कण भी आता है तो उसकी पेपर शीट खराब हो जाती है. इनक्लोजर में रहता है ये सेक्शन. ये देखो, इनक्लोजर बना है. तो यहाँ से आपका जो सरफेस है ना इनका रोल्स का, वो बहुत हाई फिनिश रहता है. मामूली सा भी उसमें कोई क्रैक हो गया तो आपकी पेपर शीट, क्योंकि हाई स्पीड पे ये पेपर चलता है कंटिन्यू, 4.5 स्पीड की स्पीड रहती है कोड ड्राइंगर से जब निकलता है. दिस इज वेरी क्लोज पिक्चर व्यू ऑफ द सिंगल ड्राइंग. देख सकते हैं, शीट है, ये रोल है, स्टीम हीटर रोल. बहुत ही हाई लेवल का ये ऑपरेशन है. ये देखो, कोई खराब हो जाती है, दिस इज पेपर. अनदर पिक्चर ऑफ पेपर रोल. फिर ये यहाँ से रोल हुआ, फिर आगे. So this is the finished roll of sheet. Everyone can see. This is all about the paper manufacturing from the raw material. If you are taking, your agro-based, then few operations are different, which are at initial. उसको कहते हैं raw material preparation. तो मेरी तरफ से तो इतना ही है। अब कोई भी मेरे से पार्टिसिपेंट क्वेश्चन पूछ सकता है। थैंक यू वेरी
Good afternoon, sir.
मच।
Sir, I have a small question, sir.
Yeah.
Sir, how to maintain the thickness of the paper?
How to?
How to maintain the thickness of the paper, sir?
Yes. You see, here the thickness comes into where the paper is being made. Here, the flow rate, measure and the speed of this belt. Here, in this section. क्योंकि स्पीड स्लो करेंगे, there are lots of factors are there. I am not going inside in depth, but mainly if फ्लो रेट ज्यादा हो जाएगा तो शीट मोटी हो जाएगी, है ना। स्पीड भी पैरेलल, दोनों का कॉम्बिनेशन। या आप समझ रहे हैं कहाँ बोल रहा हूँ? एरो चल रहा है, दिख रहा है आपको? हेलो हेलो।
Yes, Dr. It is audible, sir.
ओके, तो मैं जो क्वेश्चन जिसका पूछ रहा था उनको बात पता चली कि नहीं? हेलो चलिए नेक्स्ट क्वेश्चन।
गुड आफ्टरनून सर।
गुड आफ्टरनून।
सर मुझे एक क्वेश्चन ये था, जैसे आपने शुरू में बताया था कि पराली को हम जलाते हैं पंजाब में,
हाँ,
तो क्या हम पराली को यूज कर सकते हैं एज अ रॉ मटेरियल टू मेक द पेपर?
Few industries they are utilizing this rice straw as a raw material, but the problem with rice straw is the silica content. Again, that is a major hurdle. That is a major hurdle behind the use of this raw. It is a fibrous material, can be utilized. Cellulose material.
Excuse me, sir.
Yeah.
Yes, sir. So, except for writing purposes, we would want the paper to not absorb liquids like water. So, how do we change the composition?
No need to change the composition. I have given one section. This is a section where those properties can be enhanced of the pulp, as well as some treatment after the formation of sheet is given. Some chemicals are being applied after paper is sheet is made. That is known as coating. Okay, some chemicals are made here.
Yes, sir. So, we will be applying hydrophobic coating there.
Yes. Hydrophobic.
Thank you, sir.
Doctor, I have a question.
Yeah.
My question is that we use a lot of paper, and after a certain time that paper becomes waste. Though we recycle it, can we? I'm not from this field, but can we recycle that paper at our end? Means not going to the industry, doing something small things at maybe small scale industry level.
Very small scale industry they are utilizing. Only a single equipment used. Not here is pulper. You need.
Okay.
There is a equipment pulper, and small scale industry they are utilizing. The rag picker जो आपके घर से लेके जाता है वो स्मॉल स्केल इंडस्ट्री नॉर्मली लगी हुई है हमारे हर शहर में, छोटे छोटे कस्बों में जो गत्ता बनाती है।
Okay.
And क्या that is a very good that is a very good raw material. Only thing we have to de-ink. ये जो फ्लो शीट है शायद उसी की है, de-inking रहती है जहाँ पे।
Okay.
हाँ, अब कुछ केमिकल्स को रिमूव करके हम एडिटिव्स कुछ डिजायर्ड प्रॉपर्टीज बनानी है, उसके बाद दैट कैन बी यूटिलाइज्ड।
Okay. Another continued question is that then there are handmade papers that are very popular and are used artistically for greeting cards and other things.
Yes, that can be made even in laboratory.
Okay. Can you suggest some site or some material for making handmade paper?
I'm not getting the exact question. What exactly?
My question is that can you suggest some study material for making handmade
Yes,
paper at
yes,
work?
yes, no problem. Simply you go to internet, then just write handmade paper. How to make hand paper? You can easily get the raw material. Sorry, literature.
Incidentally, a couple of times I tried, but I couldn't get some
I will
really
send.
interesting stuff.
I will send.
If you
I
can,
will
please,
send.
it will be a real help.
Actually, you need, if you wish to establish a laboratory, then
Right.
there are suppliers. IIT Roorkee has a separate department at Saharanpur, Institute
I
of
know.
Paper Technology. Institute of
Yeah.
Paper Technology. Total
Right.
good laboratories are well equipped. That institute has. So in and around Saharanpur, those type of suppliers you can easily get.
Okay.
Huh.
Thank you, Doctor.
Yeah. Yes, ma'am.
Yeah, I think there are a few questions in the
Yeah,
chat
please.
box. I think you
Okay,
can
ma'am.
just read them out, Dr. Bansal.
Okay. Okay. It is visible to me. I can. अब मैं presentation stop कर दूं मैम अभी?
No, Doctor, we continue with the presentation.
Okay.
Dr. Poonam, can you please read the questions for the benefit of the speaker?
So there is one question.
Yeah.
Do we need to delink the waste paper before processing it for the production of some platform chemicals?
Actually, ma'am, no need to go, utilize your paper. Then you can use raw material, biomass. Biomass can be utilized to produce some platform chemicals. And few research groups are working. Because you need cellulose or maybe hemicellulose.
Right.
Yeah.
There is another question by Mr. Pravat Kumar Swain. How to make green liquor? How
Green
to make
liquor.
green liquor?
Okay.
Yes, sir.
My slides are visible to you?
Yes, sir, they are visible. They are visible, sir.
I am making the cursor on green liquor tank. Okay. आप नोट कर रहे हैं यहाँ पे मैं कर्सर घुमा रहा हूँ.
Yes, Doctor, it is this. We are noting it.
They are visible.
Okay.
They are visible, sir.
हाँ जी, green liquor में क्या है major component? Actually, when you recover black liquor from this after washing, it goes to evaporator where the 12 to 18% solid concentration has been increased to maybe 50 to 60%. And there is a recovery furnace. In a recovery furnace, that liquid is burnt. So organic mass comes as heat and emissions, and the inorganic comes in a tank, which the major component of this green liquor is sodium carbonate. So here you get sodium carbonate and then put in liquor, that becomes the green liquor. After causticization of this green liquor with lime, you get again white liquor. This white liquor is again can be recycled in the pulping operation. यदि और कोई बात पूछना, कोई क्वेश्चन फर्दर आ रहा है तो प्लीज बताइए.
There is another question, sir.
Yeah.
What are the byproduct chemicals produced during these processes? Are they toxic?
Which process?
It is just a question. What are the byproduct chemicals produced during these processes? Are they toxic?
Ma'am, the chemicals which are generated during bleaching, they are toxic. But that are being treated in the wastewater treatment plant. Otherwise, lime in the causticization section, again in the lime sludge section, you are getting your lime, and white liquor again can be produced after getting the all steps like green liquor preparation and then white liquor. पेपर इंडस्ट्री में कोई ऐसा प्रोडक्ट नहीं है जो कि टॉक्सिक है, जो बाई प्रोडक्ट निकलता है.
Yes, sir.
एफ्लुएंट है, उसको हम बाई प्रोडक्ट नहीं कहते. हेलो.
Hello, if any other participant has any query, he can come forward. Hello, Poonam ma'am.
Yes, sir.
I think there are no more questions, I suppose.
There are no more questions, but a lot of people are really happy with the with sir's presentation, and a lot of messages are pouring in. Sir, thank you so much. The talk was actually very informative and very interesting.
Thank you so much, ma'am. Actually, please, I am just stop sharing. Then I can on my video.
Yes, sir. Sure, you can on your video, sir.
Yeah.
Because speakers, the delegates would like to see you.
yeah, thank you so much. Actually, आज मेरा उतना ना थोड़ा सा मेरी बॉडी ठीक नहीं थी, तो मैं उतना भी फॉर्म में नहीं था, लेकिन फिर भी ऐसी बात नहीं है, मेरी ना आई में इन्फेक्शन हुई है.
ओहो, अच्छा, okay, sir, okay. Oh. But otherwise, the session was very interesting, and so many messages are there.
Okay,
it's not possible for me to read, but I have conveyed to you that the delegates are very happy with the session, and on behalf of all the organizers, sir, we thank you for sparing valuable time, and in spite of little bad health also, you were, sir, so full of energy during the entire course of session. That is commendable.
Thank you so much, ma'am.
That is commendable, sir.
So nice of you.
Thank you so much, sir. Thank you.
Thank you. आप मैम बच्चों को बोल सकते हैं, किसी ने मुझे से कांटेक्ट करना है, मेरा ईमेल इज अवेलेबल ऑन आवर वेबसाइट एनी टाइम. They can contact me with regard to this lecture or whatever I do some work in the area of environment. Professor Bansal can easily help.
Sure, sir. We will send the students.
Yeah. Dr. Saab, just for your information, that this team of ACBAI, they are also planning for a national conference in month of January. We are at the preliminary stage right now, but we hope to get a note for that from our administration. As soon as we get yes from our administration side, then we'll let you know. We look forward to your continued interaction and guidance to the participants and we all as well.
सर मैं पर्सनली कह रहा हूँ, मैं आपसे छोटा हूँ, पर आप मेरे को कभी ऑर्डर दे सकते. सबको कह रहा हूँ.
That is very humble on your part. Your authority in yourself in your field. So
no sir, no please. Nothing. ये तो सब सर गुड विशेस है.
Poonam, we can formally conclude.
Yes, sir. Sir, on behalf of all the organizers, I would like to thank Professor Kansal for his valuable inputs and very, very interesting and informative session. And I hope these kind of interactions continue in the future also, so that all the delegates and all of us are benefited from it. And I also thank the delegates for patient listening and interactions during the session. Thank you,
much,
sir. Thank you so much.
Thank you, ma'am.
Thank you, Dr. Kansal. For the benefit of the participants, I just make an announcement that tomorrow's session will be at 11 a.m. And tomorrow's speaker is Professor Sushil Mittal from Thapar Institute of Engineering and Technology. And his talk will be on nanoparticles modified microbial biosensors for pesticide detection. So the candidates, the participants from biotechnology and chemical engineering and even other fields like electronics instrumentation, they all will have interest in this area. So I just wanted to announce this thing. Tomorrow, please join at 10:45. We close this session formally. Thank you all.
Thank you.